So in the meantime, everyone joins. So you have a tracker with full of problems list, right? List of problems. Uh, would that be enough? Like, I mean, just to understand most of the concepts I have solved. I mean, to solve, yeah, I think you listed around 15 for sliding window and 15 for other concepts.
सॉरी,
That's sufficient enough?
जो लिस्ट जो जो शीट है,
Yes.
सफिशिएंट एक अच्छा आइडिया और ये एक अच्छा पोजीशन के लिए। ठीक है,
Okay.
ये जो क्वेश्चंस है ये सारे स्टैंडर्ड क्वेश्चंस हैं, तो कोई भी डीएसए की प्रिपरेशन लिस्ट होगी उसमें आपको ये सारे प्रॉब्लम्स दिख जाएंगे। तो मोर और लेस सफिशिएंट है। अगर सारे क्वेश्चन को आप समझ के बनाओगे तो सफिशिएंट है। इसमें लगभग 150 से 200 क्वेश्चन के बीच में है। तो इतने क्वेश्चंस अगर आप बनाते हो तो सारे टॉपिक्स का एक अच्छा अंडरस्टैंडिंग आपको हो जाएगा। बट देर इज नो सच थिंग एज कंप्लीटिंग डीएसए, कीप दैट इन माइंड कि इतना कर लिया तो कंप्लीट हो गया, ऐसा तो नहीं है। बट एक अच्छा आइडिया हो जाएगा आपको, मतलब सारे मेजर कॉन्सेप्ट्स आपके कवर हो जाएंगे। तो 90% ऑफ द टाइम इफ यू गो इन एन इंटरव्यू you will see questions with concepts that are covered in these questions.
Understood. I think this is like complete list of questions for somebody's in software development or something. I come from data engineering background, so for me, I think up to trees and graphs would suffice is what I think. But
Up to
what
trees and
is
graph मतलब?
like the concept still trees and graphs. I don't think they go anything beyond like dynamic programming or something. So
नहीं, ऐसा नहीं है। देखिए, अगर आप डीएसए पढ़ने का आपका पर्पस क्या है उस पर डिपेंड करता है।
mhm.
अगर आपका इफ योर पर्पस इज इंटरव्यूज, देन ऑल द कॉन्सेप्ट्स आर इम्पोर्टेंट।
Okay.
some companies don't ask much, some it is ऐसा कुछ लोग बोलते हैं कि कुछ कंपनीज ज्यादा ट्रीज ग्राफ्स पूछती है, कुछ ज्यादा एरेज पूछती है, कुछ कंपनीज डीबी नहीं पूछती है, कुछ लोग 1D डीबी पूछते हैं लेकिन 2D डीबी नहीं पूछते हैं। तो ये सारे रूमर्स है, लेकिन ऐसा नहीं बोल सकते कि डीपी की जरूरत नहीं पड़ेगी आपको। लेकिन अगर आप इंटरव्यू के लिए नहीं पढ़ रहे हो, अगर आप जनरल अंडरस्टैंडिंग के लिए पढ़ रहे हो, तो हाँ, तो स्किप आप कर सकते हो। ऐसे हम लोग जनरली डे टू डे लाइफ में तो नहीं यूज करेंगे, ऑब्वियसली। बट बेसिक्स जो फंडामेंटल क्वेश्चंस है ना, वो डेफिनेटली ट्राई टू सॉल्व इट, इवन इफ यू डोंट वांट टू गो इनटू टू मच ऑफ डेप्थ। एटलीस्ट फ्यू क्वेश्चंस, सो दैट इफ अ इजी क्वेश्चन इज गिवन टू यू, एटलीस्ट यू शुड बी एबल टू सॉल्व। होता है ना उस टाइप से, एटलीस्ट यू कैन कवर इट।
Yes, yes. The things that you solve in the class and practice
हाँ,
sessions.
हाँ।
Sure. Okay.
That's why currently we don't do any hard problems. We first want to cover all the basics. हार्ड क्वेश्चंस में क्या होता है कि ट्रिक होता है। तो ट्रिक पढ़ने का कोई बहुत ज्यादा मीनिंग नहीं है। सो हार्ड क्वेश्चंस, सॉल्विंग हार्ड क्वेश्चंस इज ओनली ओके व्हेन यू आर एबल टू अटेम्प्ट इट। बिकॉज इफ आई सॉल्व a hard question and I tell you what is a trick, then it's not practice as such. Okay, so that's why we do easy and medium questions, concept based questions.
Sure. Okay.
Guys, can someone please post in the group also if you have not posted? Then we'll start. Okay, guys, we'll continue. Let us start the session. कोई ग्रुप पे डाल दो यार, प्लीज। So in the previous class, we started our discussion with trees, right? So what all did we study? Let us do a quick recap and then we will move ahead. Okay. So we started with a basic idea of a tree, difference between a tree and a graph, and we understood that tree is a special type of graph. It's a graphical structure, and tree simulates a hierarchy or a relationship. We did a visualization of a tree, how it looks. We understood what is a root node, child node, parent node, cousin node, grandfather, grandmother, all of those things we understood. And we understood about the concept of a node, how it contains the data, and then the uh, pointers to its children. In general, it is a n-ary tree where any node can have any number of children. But we decided that we are going to focus more on binary tree where every node can have two children, right? So we came to this juncture, and then we started talking about some common terminologies around trees. So like root node, root, child node, edges, height of a tree, depth of a tree. So we'll try to solve some problems around this height and depth today. And types of trees like perfect tree, complete tree, skewed tree. We saw some examples, right? And then we started talking about some basic calculations around trees, like how many nodes it can have. If there are n number of levels, then how many nodes can be present, which are basic calculations which you can just gauge from how a tree is represented, right? And I discussed a little bit about the recursive nature of trees, right? And why we focused on this was because when we try to solve a problem, if we are comfortable with the recursive nature, a lot of problems can be solved easier in less number of lines of code than writing the iterative approach. Okay. So, but that pattern we have to build up that pattern where we can see a problem being broken down into self similar components. Okay. And then we were talking about this perfect binary tree, complete binary tree. And then we focused on tree traversals, right? And I told you that there are two ways in which we usually traverse trees. One is depth first, and one is breadth first. And I gave you a high level intuition of what a depth first is and a breadth first is. So please keep that in mind so that you have at least a high level understanding of what is depth first and what is breadth first. Okay. And then we did a deep dive on what are DFS patterns. And in DFS patterns, we learned about three different traversals. One was pre-order traversal, then in-order traversal, and post-order traversal. So pre-order traversal was root, and we go to left and right, right? We were doing like this. We do a root, sorry, we do a root, and then we go left, and then we go right. And in this again, we go left, and then we go right. So we do like this. This is the depth first. So this is pre-order, and then we talked about in order. So in order, we have left, root, and then right. We go like this. So we'll do like this and then go and like this we'll do. So this is also depth first, another way of doing depth first. And then we did post order. Okay. And then we discussed about how do we implement the pre-order. So if we want to do a root left and right, how might we implement it in Python? And we also did a small discussion on what are some common patterns that you will see when you are given questions on trees. Okay. So majorly you will have tree traversals or some variety of tree traversal. Later on, when we are solving problem, you'll get to know that problem might be phrased in a different way, but ultimately it will be a depth first or a breadth first. And the same concept will apply in graphs also. That you will see a question, and after reading the question, you will feel like, okay, this is a BFS question and this is a DFS question. It will come like that. Okay. And if it is a DFS and BFS question, then it is on the easier side when it comes to trees and graphs, right? On graphs you can also have DP. On graphs you can also have backtracking. So those are slightly on the difficult side. But if you get a tree and graph question which is directly, you can visualize it as a DFS and BFS, then it is on the easier side. At least that is what I feel from my personal experience. Difficult and easy is relative, but if you get a DF and BFS, then it is relatively easier, at least to understand and to frame the solution. Okay, compared to DP and backtracking, which we will do later. So if you're getting some questions, it can be about tree traversal, it can be about height and depth of a tree. Again, height and depth of a tree, usually recursively you will be able to get left view, right view. You will get check if two trees are same, if check if two trees are inversion of each other, check if a tree is a mirror tree of each mirror version of itself, right? Then path based solutions, right view, left view of the tree. These type of questions you can expect in trees, and this is what we will be practicing also. Okay. And we discussed about implementing pre-order traversal. So this is pre-order traversal. And we discussed two approaches in this, again, the iterative approach and the recursive approach. And in the iterative approach, we were using a stack. So we were pushing the root in the stack, and then we were popping it, then we were appending it in the result, and then we were doing the same operation for right and left. Right. So this was the iterative approach. And then we also did a recursive approach. For the first time, we wrote some recursive code where we took advantage of the fact that a tree has a recursive nature. So if we do a DFS on this, okay, if we do a DFS on this entire tree, it means that we are looking at this root, and then we are doing a DFS on this left child, and then we are doing a DFS on the right child. Okay, so whatever DFS was supposed to be done on the entire tree, the same DFS is supposed to be done on the child node also. And similarly, the same DFS is to be done on the child of the child node also. And every recursive function I told you needs to have a base case. Okay, so base case is the simplest possible case for which we know the result already. Right? We don't know the DFS of this entire tree. We don't know the DFS of the subtree. We don't know the DFS of the further subtree. But we know the DFS of a single node. Right? So single node ka DFS is just that value. Okay, or you can say that the base case can be a null node. So null node ka DFS is nothing. So that's why we wrote one base case here, that if not node, then we will just return. Otherwise, we will keep doing a DFS. So one of these DFS will ultimately reach a null node. When it is reaches a null node, then that function will return the result. Until then, it will keep calling multiple DFS. Okay. And in the recursion, I showed you that there is a recursive stack, or you can say recursion stack, that keeps track of the function calls. Okay. So this is the ground that we have covered in the previous class. We did a quick revision, and we wanted to implement this pre-order, post-order in order in lead code. So there are three questions. So we'll solve those questions, and then we will further solve some more questions. Then we will talk about binary search trees. Okay. This is the at least the agenda for today. So anyone having any questions till now?
ये डेटा
So,
स्ट्रक्चर हो गया क्या कंप्लीट? ट्री के बाद अब एक ही ग्राफ बचा है बस ना?
Sorry.
ट्री और ग्राफ दो ही है ना, उसके बाद तो कुछ नहीं है।
अरे मैं स्क्रीन नहीं शेयर किया था क्या? स्क्रीन शेयर है ना?
हाँ शेयर्ड है सर।
हाँ, सॉरी सॉरी, हाँ बोलिए, क्या बोल रहे थे?
मैं बोल रहा था कि अभी डेटा स्ट्रक्चर में है, अभी ट्री तो अभी आज करेंगे, फिर उसके
हाँ
बाद एक
हाँ,
ग्राफ ही बचेगा ना उसके बाद तो?
ग्राफ बचेगा, और ट्री में भी दो तीन वैरायटी है।
अच्छा।
जैसे कि एक प्रायोरिटी क्यू है, हीप है। ठीक है। तो हीप भी, ट्री आप समझ लोगे तो हीप भी आपको समझने में आसानी हो जाएगी। हीप भी हमें
हम्म
पढ़ना है। और एक ट्राइज बोल के एक डेटा स्ट्रक्चर होता है, वो भी हमें पढ़ना है।
हम्म।
सो ट्राइज इज ऑल्सो ट्री लाइक स्ट्रक्चर, दैट ऑल्सो वी हैव टू स्टडी, बट ट्राइज इज सिंपल, वी कैन डू इट इन
तो
वन
इतना ही
वन और
मतलब
टू
कि पढ़ना है
क्वेश्चन।
पूरे डेटा स्ट्रक्चर में, मतलब जितना आपने
हाँ,
बोला।
मोस्टली एक हैशिंग भी होता है, हैश बेस्ड स्ट्रक्चर।
हैश तो इसमें डिक्शनरी होता है ना पाइथन में?
हैश पाइथन में होता है, हैश बेस्ड स्ट्रक्चर।
अच्छा।
सो इसमें हैश में व्हाट आई थॉट वाज सेपरेटली विल नॉट स्टडी, बिकॉज हैश का on from scratch implementation is not there. Usually when we study hashing, it is applied on different questions. So as in how we do questions on arrays or strings, hash is automatically implemented. So hash डिक्शनरी हम लोग यूज करते हैं, जैसे टू सम वाला प्रॉब्लम यूज किया, स्लाइडिंग विंडो हमने यूज किया, तो हैश स्ट्रक्चर्स उसमें दे आर बीइंग यूज्ड. So already you know about hash. Separately, there can be some theoretical discussion of hashing, but it is not of much use. But we will do it later. But in terms of practice, there is no such question dedicated to hash.
लेकिन
Hash is
जो
used along with array, or along with strings, or along with trees, like that it will come. Graphs. So everywhere, every question, every now and then you will see that hash map will come.
अभी इंटरव्यू में तो ये डायरेक्ट ये थ्योरेटिकल तो नहीं पूछेंगे ना, उसके बेस्ड पे प्रॉब्लम ही रहेगा ना?
हाँ.
Sir, I have I have just one quick question. Can you please refresh the depth and height of the tree there?
Sorry, what?
Depth and height of the tree. No,
Depth and height of tree, what?
no, for any node, the for the depth should we should calculate from root to given node, right?
I've explained yesterday 2-3 times, sir.
Yeah.
See, depth is number of edges in the path from root to that node. Okay. So if you have a tree, suppose you have a tree like this. हो गया काम उसका. Okay. Tell me what is the height of. Tell me what is the height of this node. And what is the depth of this node?
So depth is two edges, right? Number of edges from 10 to 60. We have the two edges for depth.
This is this one depth. What is the depth of this? Or what is the
What is
height
the
of
depth?
this? What is the height of this?
Height.
Height is 20, 50, 120 means
20,
till
50, 120. This is the height. What is the definition
Okay.
that I gave you for height? That
till that.
from node to leaf node.
Okay. Answer should be the two, right?
Answer is 2, but how?
From 20 to leaf, right? Okay. Got it. Actually, in the okay,
So this is also
22.
leaf, no? This is also leaf.
Understood.
Longest.
So longest path. So this is the longest path. So that's why height is
2.
2. And what is the depth? Did you understand or not?
Depth. No, depth means bottom to top. I think from the node to root, right?
From root to the node.
I think bottom to top, yes. The root to
Not
node,
bottom to
yes.
top, opposite. Bottom to top is height.
Okay, bottom to top is height and top to bottom.
Yeah, so this, I told you that this is level 0, this is level 1, this is level 2, this is level
Yeah,
3. So what is the height of this? Height of this is 1. Sorry, depth
yes.
is
Depth is
1.
1.
Depth
Yeah.
is 1. What is the depth of this? 1.
The depth is 1, 2. Yeah.
2, not 1, 2. This is the second level. That's all. That only I have written here. You can see. The
Yeah.
depth is number of edges in the path from root to that node. And height is number of edges in the longest path from node to a leaf.
Okay. But generally it is helping to find the number of elements and just is kind of the size plus 1, right? For that perspective, are we using this component, height and depth?
For what?
In the programming area, why do we use the height and depth? Is only to calculate the number of element and number of nodes like this? What is the use of those height and depth?
Based
When
on
we
the application, there can be multiple usages.
for when we
What?
solve any problem, just we are counting the number of elements. So are we using like this?
Yeah, there will be questions
Yeah.
on height and depth.
Okay. Okay, fine.
सर प्री ऑर्डर में ना रिकर्सिव में जाओगे तो प्री ऑर्डर माने रूट फर्स्ट लेफ्ट एंड सेकंड, राइट? कोड में दिखा हुआ कि देखो पहले आपने लेफ्ट को पहले रिजल्ट को किया, पर उसके बाद में लेफ्ट किया, राइट किया. बट सेम इटरेटिव में ना दूसरा इसमें पहले राइट को हैंडल किया ना सर, नॉट राइट. इज देयर इन लाइक हार्ड कोड वैल्यू मैंने रिकर्सिव मैंने लेफ्ट आएगा फिर राइट होगा, ऐसा कुछ नहीं है.
नहीं.
ऐसा कुछ नहीं.
क्यों पहले लेफ्ट डाला इसमें, यहाँ पे क्यों पहले लेफ्ट, यहाँ पे पहले राइट किया, लेफ्ट किया फिर राइट किया, और यहाँ पे पहले राइट किया फिर लेफ्ट किया? उल्टा है दोनों में, है ना?
हाँ उल्टा है. हाँ सर.
क्यों है उल्टा? उल्टा क्यों है? मैंने बताया था कल ये चीज कि जब आप स्टैक में पुश कर रहे हो किसी चीज को 8, 5, 20, guys, please pay attention to this, okay? That's why, see, you have to do a dry run. You don't have to read the code. Suppose I have written this. Do a dry run. Then you will understand. Okay? Make that a habit.
So do your dry run means can we run in IDE or lead code or something?
Array, After
Or just write the procedure, right?
no, after
Sir,
doing so much lead code problems, today you are asking me what is dry run.
no, sir. Dry run means you have written some steps, right? One by one, like
No,
this.
no,
In
it's
the
not steps. He told left side code you written and he told to evaluate each number, right? How
I
it
am
going?
saying that what is dry run. I have explained dry run in every question I'm doing on dry run. See, what does it mean? It means that I've written some code here. Okay.
yeah,
I've
yeah. That's it, sir. That's what I'm
try
clear.
to take, it's not about running the code. It's you take an example
Hmm.
and you in your mind you see after every step what is happening. That is dry
Okay.
run.
We can make a note and try to
Step
work
by
it out.
step. Every
Okay.
day I'm doing no. See what I'm going to
Hmm.
do is a dry run. See, what does the code say?
Okay.
Code says that take a stack. Fine. I will take a stack. This is what is dry
And
run.
this, okay, okay,
This is
got
a
it.
stack.
We need to
Okay.
make it
And
noted.
this is
Okay.
the result. These two lines of code. Stack bana diya,
Hmm.
result we have done. Now what does it say? While stack. And stack mein I'm putting root. So root is 8. I'm putting 8 here. Okay.
Hmm. Yeah.
Till here I've executed. These two lines of code I've executed. Yes or no?
No, no, it's not. No, just variable. That's
Stack I've created, result I've created. No.
yeah,
Stack
yeah,
is here,
correct.
result is here.
Yes.
Result is empty, stack is having root. Now what does it say? While stack, which means
Hmm.
stack there should be some value. So stack there is some value. So what is the code saying? Code saying that node is equal to stack dot pop. So I have to
Hmm.
take out this value. This is my node.
Correct. Yes.
Then it is saying result dot append node dot data. Node dot data is what 8. I will append the 8.
Hmm.
Okay. Then it is saying if node dot write is there because this is 5 and this is 20. So node dot write is there. So it is saying stack dot push node dot write. So I will push
Hmm.
20 here. This 20 is not 20, it is 20 ka node.
Hmm.
Okay, and then it is saying node dot left. Stack dot push node dot left. Node dot left is 5.
Five. Five.
Okay, and this work is done. This loop is over. While loop is over. This while
No,
loop is over till here.
not. Yeah, that till years done. But we need to iterate again, right? The stack is not
One
empty.
loop is over. No. Now again we will go for
One,
another iteration. One iteration is over.
correct. One iteration is over.
Over again we will go to this while stack. While stack is there. So it is saying
Five.
node is equal to
Not
stack
equal
dot
to
pop.
five. Five. Five we
So
can.
see what I'm doing here. This is dry run.
Okay, okay.
I have taken one example. I have taken the code and line by line I'm running it and simulating it.
So how are you using this notepad, sir? Are you using any tools or something for the dry run perspective? I'm asking.
Just take a pencil and a pen paper on your.
Then okay, got it. Okay, all right.
Take
We
a
need to
note.
make it step by step. Yeah.
Yes, yes. I've been saying this since day one. Take a pen,
Yeah.
take a copy, draw the node, and write your code, and then draw it. You have to do it in an interview. When
Okay.
you are given a question, you will not be given examples. You will not be given anything. You will just be given a question. You have to assume. You have to draw this tree on your own. You have to write this code on your own, and then you have to run your code on one example. And from there, you have to think of edge cases.
Yeah, sounds good.
Please go and check the notes of the first class where I told you step by step how you have to approach the problem, understanding the problem, reiterating the question back, then explaining the question
Uh,
back,
Explain the question, pseudo
then
codes,
brute force solution, dry
brute
run of the brute
force.
force solution, propose the optimization, how to go for optimization. Also, I've shown you if you are doing O of n squared, try for O of n. If there are certain situations, try for O of log n. I've given all that. Then write the optimized code. Do a dry run of the optimized code. That's what we have been discussing. So now the question is that why did I do right and left first? Because if I do right, then right goes here and the left goes on top. So
Hmm.
when we are fetching it back, I don't know who was asking this question, but when we are popping it back, then we will get left first.
Hmm.
That's why we are putting
Correct.
it ulta. We want to process 5 first and then 20. So we want to process left and then right. That's why while pushing, we are pushing right and left. So that because it's stack, you pop it is a LIFO. So 5 will be pushed last, then 5 will be taken out first. That's why we are doing ulta. So you see, we did 20 and then 5. Now while processing, 5 will come first. So I have 5.
Okay.
Then again we will run this code. Result dot happened 8, 5. Then stack dot push. So this is having 13 and this is having 7. So
Sure.
what will I do? I will push 7. This 5 is deleted.
Yeah,
I
13
will
then.
push 7. Then I will put 13. Then again I will pop. So what will I get?
13.
I will get 13. 13 becomes my node. Okay, again 13 is having nothing. So we'll put 13 here, and then if node dot right, this condition is not satisfied. If node dot left, this condition is also not satisfied. So we will simply add 13 and we will move ahead. And then we'll go to 7. So how are we traversing? If you see, you went from 8 to 5, 5 to 13. We went like this. Did you see? And then after that,
Yeah.
we will go to 7. You see, 7 is next. So what we are doing? We are going like
Some
this
topic.
and like this.
Correct.
Can you see the depth?
Yeah,
If
depth
we had
is.
more trees, then we'll go like this.
Yeah.
Like this, we'll keep growing like in a depth. Again, if there was here, we would have gone depth, depth, depth. So we'll explore entire this one, which will be root and then left. Same story we will do on right also. We'll go here, then we'll go here, go here. So we'll do this. Like this we will go.
Yeah, root left, right. Huh?
Root left, right. So you can see here, what was the result? 13, 8, 5, 13,
7 is
7.
coming again. Yeah.
Okay.
Then
And after
again.
that, this whole thing is done.
Hmm.
Root is done. Then we'll go to right. So right, what we'll find? 20. And then root
20,
left 15.
15.
So this is the
That's it.
result final.
Okay, sir. This is the pre-order. I understood. What is the business usage of this? I think is it just for concept perspective or you
Concept.
deriving? Yeah. Okay. There any business importance on this to find the pre-order or post-order or something? It's just for logic only.
Directly you will not find difficult to relate it to directly to a business, but there are a lot of applications of depth first search.
Okay. And what is the efficient way to step forward, right? Which is the best way to move forward?
Best means?
No, for example, if we use this kind of the algorithm, we can go to choose the right directions. So, which is the best directions? For any network related business application, which is the best direction to go move forward to implement this kind of algorithm? So, I'm just talking about the business usage. Is
See,
it
directly,
applicable? Yeah.
directly, you are not going to do all these trees and all in a business problem. These are all implemented by already implemented. For example, when you go in your operating system, okay, and you want to see your entire, you see this, okay. How do I show? Directory structure in an operating system.
Correct. Yes.
I gave some real life examples yesterday also, like of in order how things are used. But you can see, can you see this directory structure? If you go like this, from here to here to here to here to here, this is one depth. So when you want to search for it, you can search like this. Alternately, you can also search like this. Okay. For example, you want to find the shortest path. Okay. There are a lot of applications.
To make the efficient search, got it.
For example, you're having some graph like this. Or let me not draw graph because we have not learned graphs. Let me draw a tree.
Sir, in like LinkedIn, friend request, friend list,
Everywhere
or
trees are
social
used.
media,
Graphs are
in
used
that.
a lot of places. See, if I'm
Hmm.
asking you, okay, what is the shortest path to this from this? If I want to reach here from here, what is
Mhm.
the shortest path? How will you find?
Depth, no, from root to
It is a breadth first
this.
search, BFS.
Oh, okay.
You will find that, okay, this is level 1, this is level 2, this is level 3. So this is, sorry, this is level 0, this is level 2. So this distance is 2. Now, can you think of example of why you will want shortest path?
Because we will go to reach the destinations, no, as soon as possible.
Yes,
That. Yeah.
yes. You have a maze kind of a problem like this. You are having one robot here standing, and there is some kind of a treasure here. Okay, you want to find out
Mm.
what is the shortest path for this person to reach here.
Mm.
Okay, you can say that it can reach like this also. It can reach like this also. Correct?
Yeah.
It can reach like this also. Which is the
Yes.
shortest path in a graph? That will be application of one of the traversals.
Okay.
You want to sort something. There for topological sorting, DFS will be used. Now you don't know what is that. Cycle detection, DFS will be used. Okay. So see, there are a lot of applications, but when you are learning about this, don't pay too much attention to where it will be used. Because it is
Okay.
possible that right now you might not. Earlier also somebody was asking me this question, and I told you, okay, that I can give you some 20 applications of this, but you may not understand it. So don't keep your motivation that, okay, what I'm learning, whether it will be directly applicable to business or not.
Okay. Okay.
In
Fine.
many things, it is a good way to learn that, okay, whatever I'm learning, does it have any business application or not? But for many things that you learn, they are so low level that it is difficult to have a direct business application. It is there, but for you to imagine that, it will be difficult. When you're learning data science, high level things, data science, which is on a high level uh, abstraction, when you're learning data manipulation, data visualization, there you can say that, okay, where it will be used. But if you're learning on a very low level, computer architecture level things, difficult. Suppose you're learning about how a RAM works,
Okay.
right? How memory is allocated. Can you relate that directly to a business? No. You are learning engineering.
Correct.
It is difficult. It is there. Application is there. But you will understand the application little bit later. Scheduling jobs, it is used. When you want to schedule some jobs, it will be used. Operating system is using, for example, this is stack. Earlier you were talking about what is the application of a stack. Now, if I tell you about recursion stack, you will get confused. But you see, in recursion, operating system is using a stack.
Mm.
It is also using a queue in many places. Now, when I talk about BFS, there you will see application of queue. Queue will be used. You will see. But while learning queue, if I tell you that application, then you will not understand it because things are in a sequential way. So don't get demotivated if you're not able to relate it to something. Just understand the concept that what is happening, how it is happening, how am I going to use it to solve the problem. Application is there. I'm not saying application is not there. But at the time of learning, also learning the application is a little bit difficult. But I will try to tell you wherever application comes. But when you learn about graphs, there just wait for 2 3 classes. When you learn about graphs, then you will appreciate, oh, in trees we learned this, no
Okay.
application is coming. You will get that application, don't worry.
Okay. Fine. Yes.
Yesterday somebody was talking to me about dependency issues. Dependency issues are
Mm-hmm.
also a graph problem.
Mm-hmm.
Now you might ask how. So that is difficult to explain, but it is also a graph problem. Dependency, when you import certain libraries, sometimes it goes into a circular import. You will see in graph problems that how do we detect cycles in a graph, cyclic graph, acyclic graph. So when there is a dependency resolution, when you are importing a file which is in turn importing that same file, So self-import happens. So in that case, it causes a loop. That is also application of a graph. So you will get applications. Don't worry about that. Guys, this
Okay.
pre-order traversal, is it clear to everyone? Can we write the code for this?
Yes.
Did you guys try to write it on your own? I think that's what we agreed yesterday. Chalo, let us write it. So what did we discuss? I also forgot. Let me go and read the code. Okay. So we said that we will create one stack, we'll create one result. Okay, fine. So let me write, this is the iterative solution using stack. So when we do DFS, we will use a stack for it, for iterative. And in BFS, you will see that we will use a queue. Okay. So what we will do, we'll create a stack and we'll call this root and we'll create one result. So result will be empty. Then we'll say while stack. Okay. First we'll pop the node. So node will be equal to stack.pop. Okay. And that node value we will append. So what we will do, first we will visit the node. Okay. Then visit the then DFS on left node, and then we will do DFS on right node. This is the order in which we have to work. Okay, so we'll visit the node means which we will add. So we'll say result dot append node dot value or data value. Okay. Then DFS on the left node. So DFS on the left node first and then right node. So that's why we will add. We'll say stack dot not push append. Here I've written push, but actually we are using a list, so it will be just append. So stack dot append, what we will append? Node dot right, and we'll say stack dot append node dot left. Okay, and this will be the case if node dot left, and here we will have if node dot right. Okay, here I will write pushing right first so that left is on top of stack and then left. Okay, in the next iteration left will be popped, so we will visit the node and then we will visit the left node, then we will visit the right node. After doing all this, we will simply return.
Now I got it, sir. Why are pushing first or right? Because we want left to be top. Yeah, got stack right. Yeah.
Yes. क्या हो गया? See, we missed one edge case. What is the edge case we missed?
Empty
So
node.
if not node, return none. Is that? Cannot. If not.
Local variable node where
If
is
not root. Sorry. Output null expected. It should work. What happened? Name stack is not defined. Stack.
Robert, it's expecting null in the result.
So that's what I'm returning. So if it is empty, then traversal should be like this, empty result. Okay, so here let me make that change. I did not write here that edge case we have to handle. If not root, then return. You can return empty list, return none, whatever question says that you can return. Can we write the recursive code also?
Yes.
So what will be the recursive? Let me take this and put it in your sheet. Let me create a new section now.
For performance perspective, regressive is not better than our current approach, sir. Am I right?
No, both are similar.
Both are similar approach, sir.
Text. In some problem, you have to analyze it. In some problems where space, you are doing it in constant space. But if you're using a recursive approach, you have to give some space for the call stack, recursive call stack. So that depends, but normally they will be similar.
Through recursive operation, it perform internal stack. Those stack and our customized stack, both are the similar methods or different one?
Yes, similar.
Yeah.
Okay. So this is our iterative solution. Let us do the recursive solution. Let me reset this and in your mind, revise. Okay. What we have to do? Because I am also revising. Okay. What we have to do? We have to visit the root, then we have to do a DFS on the left, then we have to do a DFS on the right. And we need to think of the base case. Base case will be that when my node is null. If my node is null, then my DFS is also should not return anything. Okay, fine. So I'm going to do a DFS on my root. Okay. And I want to have a result. So my result will be an empty list and then I will define my DFS. Okay, so DFS will take a node. This is a function inside a function I'm just writing. Okay, so this will say that if not node, then I will just return. This is the base case. Okay, we'll return. Otherwise, what we will do? We'll say result dot append node dot val, and we'll say DFS node dot left, DFS node dot right. And I did a dry run on this and I showed you yesterday that how this is going to work. And I'll say return result. Okay. Root node, then left node, and then right node. So this is the recursive approach. Will this work? Let us run and see. Yeah, it is working. Clear, guys? See, here the tree node is already given to you. What a tree node is. So it is having value, it is having left, and it is having right.
Okay.
Come here and we'll say the recursive approach.
So let us dry run that any one elements. Then.
Already I've dry run yesterday 2-3 times. Today also I did one, just did one dry run, no?
Okay, fine. Yeah, yesterday is fine. Okay, that's fine. Maybe.
Please watch the recording. You want me
no,
to
no,
do
I
one more
watch it.
time? I'll do. Okay, fine, I'll do.
Okay.
But we have not yet
No,
started
it's not.
any
No,
class.
it's not an issue. You can forward the class because yes, today recording has been uploaded a little later. So I
Fine, watch
watched only
it. I
the.
have done it. I will do
Yeah.
it again in pre-order because I want to move ahead. Till now we have not done anything new.
No, no. If you
Okay,
have
so
already covered, it's not a
already
problem. We
covered.
can
Yesterday
continue.
already covered in
That
detail.
is fine.
Again today I will cover in. Let me do post order. In that let me cover. Okay.
Yeah,
So
yeah. Then,
let us do in order. Okay. So how will we do in order?
yeah, yeah.
In order traverse.
In order is left, root, and right, right?
Left, root, and right. Yes, correct. In order traverse. So this will be left, then root, and then
Right.
right. So how will we do this? Let me take that example here. We'll do recursive and iterative. After a point, we will only do recursive. Okay, we'll not do iterative. I'll leave it up to you to do it. But initially, I just want to show you that both approaches are possible. Okay, so this is the graph. This is what we have. Now, if you want to do iterative, or first of all, what will be the answer here?
Left, right.
What will be the in order traversal here, first of all?
13, 5.
13, 5, 7.
Yeah.
13, 5, 7. Then 8.
8. Then
15, 20.
15 and 20.
Yeah. 15 and 20. 20 and 15. From deep to traverse.
Hello.
Alo, itu
Đi rồi.
tại bạn ơi,
Mà trai đi rồi.
anh biết
Trai đi.
In order travels, this answer is clear to everyone. Now, how can we do this? So if you think in terms of recursion, recursive approach, okay, will it be similar to the pre-order one? Can I say that I will create one result, okay, and I will write one DFS. I want to do a DFS. On a node. And then what I want to do? In the previous one, what did we do? We visited the node, then we went left, and then we went right. In order, what we want to do? First, we want to go left. So if I want to do a DFS on this node, first I want to do a DFS on this node. Then I want to do a 8, whichever is the node in consideration, and then I want to do a DFS on this. Is that correct?
Yeah.
Okay.
Yes.
So first I want to do a DFS on the left child. So I will say DFS on node dot left. Okay. And then I want to add this 8 to my result. So I'll say result dot append Okay, node dot val. Okay, I will do one more thing. You might be thinking that okay, this recursion is so simple, we are just writing, but actually you will learn recursion, you will feel it is easy, and after a point then you will be confused. You'll see, oh, what is happening? Okay, and then again you will understand it for the second time, and then you might get confused for the second time, and then you will understand it again for the third time. So normally it will take you 3 or 4 times of revisiting recursion in order to completely understand it. Okay, now you might think how this result is being accessed. So this result is actually a global variable which is passed along the functions. Okay, so you need to keep those things in mind also. So what I will do one debug in PyCharm. I will try to show you line by line how this recursive code is working. Okay, so dfs node.left, then we will do result dot append what node dot
Data.
val
Value.
node dot val node dot data whatever, and then we want to do a dfs
Node dot write.
node dot write. Okay, and here again we have to think of some base cases. So what will be the base case?
Empty and null.
Base case will be that when we reach the edge or last node, there we have to be careful. We'll say if not node, then we want to return. Okay, and after doing this, what we want to do? We want to do a DFS on root.
Then
we want to
return.
return
Result.
return
Result.
Okay, so can we do one dry run of how this will work? Okay, so the first call will be DFS of root. Okay, so this is my call stack. Okay, and I will call my DFS on 8, and this is my result. Okay, so when I call this function is being called on DFS of 8. This code will not run. We will come here and we will call DFS of left. Okay, so now we are in DFS of 5. This function is being called. So again this function will call, if not node, this line will not be executed, and we will call DFS on node dot left. So we'll call DFS on 13. We'll say DFS on 13. Till now we have not returned anything. Okay, now again DFS of 13 is called. So we are coming to this line and we are going back again with a new function call. Till now we have not executed this code. This line we have not executed. Are you guys following?
Yeah.
Okay. So we are in DFS of 13. Again we will come here. This line of code will not work. This line of code will not work. So we'll come DFS of node dot left. So node dot left is what? None. So we'll call DFS on a none value. Now this line of code will work.
Returns empty.
Okay.
Yeah.
So it will return. So we will come back to DFS of 13. We actually call DFS of none. DFS of none, here you can write here that we will do DFS of none. But this DFS of none will return. So this function will be removed. And we have come to DFS of 13. So in DFS of 13, we were in this line. This line is executed. Okay. Now we will come to this line, which is the result.append node.value.
Add
So what
13
we
to
will
the
append?
result.
We will
13
append
to the result.
13. Okay. 13, and then we will do DFS of node.write. Okay. So node.write is what? DFS of 7. Okay. So DFS of 7 is called. Again, we will come here, DFS of 7. We will come and do DFS of node.left. So 7 ka left is what? Nothing. So it will not return anything. So we will come back and we will see result.append node.val. So we were in DFS.7. So we will append node.val, which is 7. Sorry. In order was what? Left, root, and DFS of 7. Node.val. What happened? After 13, we'll go back to 5. Sorry, I made a mistake.
Yeah.
Okay. Let me take back a few steps. Sorry. We were in 13. After 13, we came to 13 and we went to node dot left. Okay. So node dot left was none. It returned back and we appended the value 13. Okay. And then we went back. Okay. We'll go back to 5 actually, because this 13 is not 13 came as a result of execution of 5. So 13 has come. So we'll go back to 5. So we'll have here 13. It is difficult to imagine it, how the call stack is working, but we'll go back to 5. Okay. And we were in 5 actually. So 5, when we were calling 5, we were doing node dot left and we have done node dot val. Then we will go to node dot right. So we'll call, so 5, 13 is done. Now we'll go to 7. So DFS of
7.
DFS of 7. Now again we'll come to DFS of 7. So DFS of 7 we have to do iska left, then iska 7 and then iska right.
तो नन पे आ जाएगा. हाँ.
हाँ, तो ये तो नन दे देगा. फिर 7 पे आएंगे तो 7 will give result, this will return none for 7 dot left. 7 dot left के लिए this will return none. So we'll come back and we will do 7 dot val. So we'll put 7.
Depend कर देंगे.
Okay, I'm not putting here because lot of stack values will come, but you can imagine that 7 will come. We have done 7 dot left null, then 7 dot value appended, then we'll go and do 7 dot right. 7 dot right is also null. Okay, so nothing will happen. So we'll come back and 7 is done and 5 is also done now. 7 has returned. So 13 and 7 is run. So 5 ka business is over. We'll go back to 8. We were in function call of 8. Function of call of 8 ka left part was done. All this drama that happened was left part of 8.
Then we add 8. Yeah.
Then we have come back to 8 because initially we started with 8 root. We were working with root. So till now we have run this much code. Now we will add 8. Okay, so this line of code we will work. We'll add 8. And now we'll go for DFS of right, node dot right. So node dot right is what? This is done.
DFS of 20. Okay.
Node dot right. So node dot right is, we'll call DFS of 20. So again, we will come here. If not node, nothing. Do DFS of node dot left. So node dot left is DFS of 15. Okay. DFS of 15. So DFS of 15, again, we will come back here. Not node, we will not do anything. Node dot left, DFS of 15, nothing. Okay, it will return none. Then we'll come to result dot append node dot val. So result dot append node dot val, we will do 15 here. Okay, and then we do DFS node dot right. Node dot right, 15 has nothing. So we'll come back and we'll come back to DFS of 20. DFS of 20 ka, this part is done. Okay, DFS of 20 ka, this part is done. Then we have to execute this part. This part says result dot append node dot value. So we will append 20. And 20 ka kaam khatam. 20 ka kaam khatam nahi, sorry. 20 ka right we have to still do. This line we have to execute. So DFS of right means 20 ka right. 20 ka right is nothing. So it will give me none. So once right is executed, then this DFS of 20 has run completely. We will run, we'll remove DFS of 20. Now what has happened? My stack is empty. So if my stack is empty, now nothing is to be done. This root wala function, has finished the execution and this is our answer. You can imagine it like it started with root. It started the work with root and then it went here and it forgot about 8. It started working with 5. So until it finishes 5, it will not go to 8. While working with 5, it went to 13. Okay. Once it has finished 13, then it will go to execution of 5. Execution of 5 mein left wala part is done. Middle wala part we will append. Then we'll go to right wala part. So while executing 7, again we'll go to left. Again we'll go to right. If left is having more trees, same logic will continue. So you can imagine this. Try to do a dry run and create a stack like this. Of which function is called where and what is the status of each function. But you don't have to do it all the time. If you understand once, then there's no need to do it every single time.
Yeah, just one question. How does it go from 13 to 5, sir?
13
I
to
understood the 13 to 5, second element. I think I understood 13 is written. Then how does it?
first we are doing DFS of 5.
Yeah,
So when you do DFS of 5, there are 3 steps in it. First you will do DFS of 13, correct? Left,
yeah, yeah.
node dot left. Then you will append 13, append 5,
Okay.
append node dot value. Node is what, 5?
Mm-hmm.
And then what I will do? DFS of right, which is 7,
Okay.
correct? So
Yeah.
DFS of 13 when you are doing, again it will do what? It will do DFS of the left node of 13. What is the DFS of left node of 13? DFS of none.
None. Yeah, DFS of none. Yes.
Then it will do append 13,
Yes.
and then it will do DFS of none.
Yeah, DFS of none. Yes,
None.
correct. Okay.
So it will do DFS of none, which means nothing. Then it will append 13. Then it will do DFS of nothing. So DFS of 13 is over. Okay. So this part is done. This part is done. Sorry.
Yeah.
This part is over. Then it will append 5. It will append 5. Append 13.
Okay.
Append 13. Then append 5. Append 5.
Okay.
Then it will go to DFS of 7.
Okay.
So DFS
I
of 7
think
will be what?
DF of 7, none only.
DFS of none. Then append 7.
Append 7.
And then
Yeah.
DFS of none.
Yeah, correct.
Correct. DFS of
Then
none will not give anything. DFS
then
of 7
8 is
will
gone.
append 7. I have appended 7. Then DFS of none. Nothing. Okay.
Okay.
So all of this
Yeah.
is done. But who called this DFS of 5?
8 on.
DFS of 8. DFS of 8 was called DFS of 5, no?
Yes, correct.
And in DFS of 8, what will happen? First, we will do DFS of 5 and then we will do append 8. Can you see the pattern?
Yeah, yeah.
We'll do append 8 and then we will do what? DFS of 20.
Yes.
Correct? So after doing DFS of 5, this much was DFS of 5. Then what did we do? Append 8. So append 8. And
Yeah,
then do
append
DFS
8.
of 20. So DFS of 20 will do what?
DFS
DFS
of
of
15.
15. And then append 20.
Yeah.
And then DFS of none. So DFS of 15 will do what? DFS of none, append 15, and DFS of none, nothing. Then it will append 20. So it will append 20. And then again DFS of none. So DFS of none. So story over.
Okay. So I think in the when execute the code, right, DFS of node dot left mean until none it can repeat again and again, right?
Yes.
In the regression. Yeah.
This node dot left will further call node dot left. Again, it will call node dot left. It will keep calling until it hits a none.
None. Yeah.
That's why we need a base case.
Got it. So okay.
I made it like a mess. Wait 1 second. Let me clean it.
So once it returns none only, then the
Yes,
next element
then only it
will
will
be
return. Function has to complete the execution. It has to have a return statement. Then only it will go from this line to this line.
Yeah. Okay. So return means it can go to the out of the blocks depend
It will
statement,
finish.
right?
The function has finished, and it will come out. So if you are having this line, node dot left, this line will execute when this function is returning something.
Yeah, none only. Yes.
So it will return when So in
Yeah.
recursion, there are two important things. One is base case is very important. This is the solution. So what we are doing in recursion, we are taking a bigger problem, okay, and we are creating a smaller problem out of it. So we are saying that if we want 8, 15, 20, 30, 40, 60 and 80. What I'm saying is that if I want to do a traversal of this node, okay, then I want to do a traversal of this node. So whichever function I'm using to traverse 8, same function I'm going to use traversal of 15 also. And in order to do a traversal of 15, I need to do a traversal of 30.
Okay.
So where will it end? I will say, okay, for traversal of 30, I have to do further. So I will keep traversing, but where will it end? So I have to give some ending condition.
When node is not no values on left and right.
So the ending condition is that case for which, so I don't know the DFS of 8. Do I know the DFS of 8? I don't know the DFS of 8. But in order to call DFS of 8, I need to have DFS of 15. But do I know the DFS of 15? No, I don't know DFS of 15. So for that, I need to know the DFS of
30.
30. But do I know the DFS of 30? No. But do I know the DF for 30? I need to have DFS of none. But do I know the DFS of none? Yes, I know. So when I know this, then I can know this. If I know this, then I can know this. If I know this, then I can know this.
Got it. Okay.
Right? It is I will give you an example of recursion. Okay. Suppose you want to factorial. Do you guys know factorial?
Yes.
Suppose you want to do 5 factorial.
5 into 4 into 3 into
So
2
what do you
into
do? You do 5
5
5
until
into 4 into 3 into 2 into 1. Okay.
yes.
But I don't know the factorial of 5. But can I say that this is 5 into 4 factorial?
Yes.
But do I know 4 factorial? No.
4 into 3.
So in order
Yeah.
to find 4 factorial, I will say I need to know 4 into 3 factorial. But do I know 3 factorial? No. So in order to
No.
find 3 factorial, I will do 3 into 2 factorial.
Yeah. 2
Okay.
into 1.
So if you break this down into a problem, what is this? This is n factorial is equal to n times n minus 1 factorial. So you will say, what
Yes.
nonsense? Because in order to find a factorial, you are using a factorial. But this will make sense if you have a base case. Because you will say, okay, 2 factorial, I don't know. So I'll say, okay, 2 factorial means 2 into 1 factorial. But do I know 1 factorial? No, I don't know. So I'll say 1 into 0 factorial. Now 0 factorial do I know? Iska answer do I know? Yes, iska answer I know. Iska answer is 1. So if I know this, then 1 into 1, this becomes 1. So if this becomes 1, then this becomes 2. If this becomes 2, then this becomes 3 into 2 is equal to 6. If this becomes 6, then I know this is 4 into 6, which is 24. If this becomes 24, then I know that this is 5 into 24, which is equal to 120. So I'm able to find 5. 5 factorial is equal to 120. So this is only
Got it.
recursion.
Yeah, got it.
So if you want to write the code for this, how will you write?
Function, we can depend on function.
You can say factorial of n.
Yeah.
Factorial of n. I'm just giving a little bit about factorial. No, sorry, recursion. So what will you say? You will say, I will return
function n
n times
into n minus 1
factorial
time. Factorial of n minus 1.
n minus 1. And I will say if n is equal to 0,
n equal to 0,
then return 1.
return 0. Fine.
Okay. Did you understand how one function is calling another function? So we can do this, but if we know some base case, we need to have some base case. Can we write 1 factorial? And I will take n. Okay. And I will say return n times factorial of n minus 1. And here I will write if n equal to 0, okay, return 1. Can I say factorial of 3? Okay. Can I see put here? I will print calling factorial of n. See, I called factorial of 3. The factorial of 3 is calling factorial of 2. Factorial of 2 is calling factorial of 1. It is calling 0. So when this function is returned, so here you can see the recursion stack, what recursion stack I was showing you. Here you can see, first what I called factorial of 3. If you understand this, it will be helpful for you in your trees. 3. Now for calling this 3, I'm calling factorial of 2. This factorial of 2 is calling factorial of 1. This 1 is calling factorial of 0. This is returning. This is returning some value. So when this is returning some value, I will go back to this. Now factorial 1 will return the value. Then I'll come to 2. 2 will return some value. Then I will come to 3. 3 will return some value. Stack is empty. Then I will get my result, which is 6.
Okay.
You can use this to find other patterns also, like 1 plus 2 plus 3 up till n, and all those patterns also you can use. But you need to have a base case, which you know. Okay, guys, can we move ahead? Can we write this code in order traversal in
Okay.
our lead code? So we have solved some questions. So we'll mark that.
But can we also to solve the problem in stack and linked list as well, sir? We can do it, right?
How will you
For
do
the
in linked
same
list?
linked list also for the movement, right? Left and right movement. It's not possible.
No.
Okay.
Trees.
Well, we
So
can do in stack and queue only then.
stack,
Or
not queue, stack.
stack. List as well, right? List.
No, no, no.
No.
So here we can say pre-order traversal. Pre-order
So with the
traversal we have done, and let us do in order traversal. In order traversal.
in order traversal is done.
So we'll do 94. Okay, so let us write the code. So we'll write the recursive code. So what we'll do here?
Node.
We'll take a stack. Sorry, we'll take. We are doing recursive. So we'll say we'll call DFS on the root. Okay, and we'll define a DFS function. This DFS function will take the node, any node. Okay, and we'll have one result here. Okay, so here we'll come and we'll say if not node, then return
20.
Otherwise, what we'll do? First DFS on left.
Yes.
So we'll say DFS of node dot left, then visit the node. So we'll say result dot append node dot val. Then we'll say DFS on right. Okay, so we'll say DFS node dot right, and we will return result. Okay, it is working.
Yeah.
Can you think of how we will do it in an iterative way? Using stack, using in-order traversal.
Yeah.
Similarly, we can also do same logic. We'll not have to change much code. We can also do post-order traversal. So let me copy this code.
Mhm. Mhm. So with only stack and recursive only should we resolve the problem? This kind of problem.
Okay, this is the recursive code. So how can we do the iterative version of this code? I've already given you the iterative for pre-order. Can you use this and think of how we can do
Hmm.
the in-order traversal? What we will do? See, this will be a very good practice for your stack also. If we do this, then I will leave the post order for you. You do it on your own, and we will discuss level order traversal. But how can we do using iterative approach? Guys, are you following or are you lost?
Yes. Yes, we are following. So, we need to depend the nodes that we can iterative
Iterative approach.
left.
Okay, what was the tree we had? This was the tree.
Yeah.
8, 15, 20, 13, 7,
Yeah.
8, 15. Okay.
Mm.
Tell me iterative approach for this. This is the last time we'll discuss. After that, we'll just move.
Yeah. So I iterate the stack there, first of all. We need to traverse until
We have to start from where?
Stack
from root.
from 8 root.
Start 13 से करेंगे.
How can we directly start from leaf?
I will create a stack and then result array.
Suppose you start with 8. Okay. I'll just give you a hint. Line of thinking, you complete it. Suppose we put 8. Okay. And then we put 15. And then we put 13. So 8, 8 dot left, 15 dot left. And 13, 13 does not have anything. Can we say that our current is equal to root? Okay. And I will say while
Well,
current
current.
stack dot append current. Okay. And we'll say current is equal to current dot left. Does it make sense? So we'll put 8, then 8 dot left 15, 15 dot left 13. We'll create one stack here. We'll put one result here. Once you have reached 13, then what you have to do? Once you have done this, then what you have to do?
Move to the right.
We have to take out 13 and we have to process 13 because we have to start from 13. So we'll say Kumar, you're saying right. Node is equal to stack.pop. Okay. And our result is here. So what we have to do? We have to put the value. We have to say result dot append node dot value.
Yeah.
And then what we have to do?
Then backwards, no? 13 to 15, 13.
Think in terms of pattern. What you will do after
Then,
this? We have done 13. After doing 13, what we have to do?
then pop it again, the 15. 13, once we move the 13, right? After we append the node value, we can pop it again, the next element, until stack clear. No, until it's not stack clear.
Then we will again append stack dot top.
Yeah.
So I think then we'll again append stack का top 15.
इसमें 2 लूप लगेगा मेरे हिसाब से. मैं भी सोच रहा हूँ.
सर फिर से करंट अभी स्टैक का टॉप को करंट बनाएंगे देन व्हाइल लूप विल अगेन रन ऑन 15 now.
एक मिनट. हमें करना क्या है? हमें 13 पर आ गए. उसके बाद 13 हमने कर लिया. 13 का राइट और लेफ्ट प्रोसेस हो गया क्योंकि 13 आखिरी नोड है.
13 15 आना चाहिए सर. 13 15 7.
करंट इज इक्वल टू करंट डॉट
13 के रूट पे जाएगा, 15 ऐड होगा, देन 15 के हम लेफ्ट को प्रोसेस करेंगे, लेफ्ट ऑन राइट चेक करने के लिए.
करंट डॉट लेफ्ट. यहाँ तक गए हम लोग तो हमने 13 ऐड कर दिया. 13 आ गया. इसका इन ऑर्डर ट्रैवर्सल है क्या? एक मिनट. 13 15 7 8 15 20 है ना?
15 20
13 will be current. Then if there is no left and right, in that case, we should check current -1. That should be current. And left already done. So we can use the right.
राइट पे जाना है, ये तो बात है तय. करंट इज इक्वल टू
Current -1.
करंट डॉट राइट.
बिफोर मूविंग राइट वी
No,
हैव टू
in the
इंसर्ट आल्सो.
-1 कैसे होगा?
13 was the current. There is no left and right, right?
Current is equal to current dot right.
That is none only, no?
That is none. So current dot left, the current dot right, that was none. Now we appended 13. Now the current should be current -1.
-1 कैसे हो सकता है? -1 का क्या कोई सेंस नहीं है.
बिफोर मूविंग टू राइट सर वी हैव टू अपेंड रूट आल्सो ना 15.
हाँ, वही मैं सोच रहा हूँ कि रूट तो अपेंड करना है, लेकिन वो पैटर्न में कैसे फिट होगा. मैंने भी बहुत दिन से देखा नहीं. एक मिनट. करंट इज इक्वल टू रूट व्हाइल करंट डॉट अपेंड. करंट हमने ऐड कर दिया स्टैक में. करंट डॉट लेफ्ट. करंट इज इक्वल टू करंट डॉट लेफ्ट 15. करंट इज इक्वल टू रूट नोड इज इक्वल टू स्टैक डॉट पॉप. नोड हमने निकाल लिया 13. नोड हमने निकाला यहाँ पे 13. current dot right. हाँ ठीक है यहाँ पे यहाँ पे चेंज होगा while stack or current. ठीक है, and here we will result. Now I'll do a try run. I'll show you it. I hope this should work. See now what will happen. I have a result and I have a stack. I also have a current. Right. So we will start our job. We'll start from beginning. Okay. What is it? Current is equal to root. So we are having current here. Okay. Stack is empty. Current is equal to root. So this condition is true. Okay. So while current, we will, the purpose of this code, what is the purpose of this code? Why are we writing this inside loop?
To reach the leftmost.
To traverse, yes, to traverse to leftmost node. Because that is where we are going to start. So while current stack dot append current. So 8 and current is equal to, this is a loop, okay? This is inside this loop and this is like this. So there is one while loop outside, there is one while loop inside. So stack dot append current. Current is equal to current dot left, so 15. And 15 dot left is equal to 30. So this loop is over. Now we are coming to this line. Node is equal to stack dot pop. So node is equal to 13. Okay. Result dot append node dot val, which is 13. ठीक है. Current is equal to current dot right. Current is equal to current dot right. Where is our current right now? Current
There
is
is
at
none, right? It's a none only, no?
while current dot left. Okay. So current dot right, nothing will happen. Okay. So this loop, whole loop will finish. This whole while loop will finish. This inside while one iteration of this while loop is over. Then again
Yes.
we will go inside and we will see what does it say. Current has become none. So while stack or current. So current has become none, but stack is having one value. Stack is having value. So again we will pop current is none. So this loop will not work. This loop will not work. So what we'll do? We'll do node is equal to stack dot pop. What are we going to pop now? 15. Did you see? We reached from 13 to 15. That was only the problem.
Yeah.
Okay. We have reached 15. Result dot append node dot value 13 and 15.
Then
Okay.
current,
And then current
right.
is equal to current dot right. That's what we wanted to do. From 15 we will go to 7.
7.
Okay. So current is equal to current dot right. Okay. So 7
The
we
current
don't have
is
to.
null right now.
Sir, current is null.
Current is still null. Where current was never assigned again.
Current was never assigned again. 13. Current is equal to current dot right. Current. 13 we went to 15. Stack dot pop. Current is equal to current dot right. 15 को करंट बनाना पड़ेगा. Current is equal to current dot right.
Sir, maybe current equal to node dot right.
Current is equal to
Node dot right.
current is equal to node dot right.
कैसे सर जो टॉप पे है राइट ना 15 वाज ऑन द टॉप ऑफ द स्टैक सो उसको करंट बना सकते हैं.
करंट इज इक्वल टू, यहाँ से यहाँ जाना है ना अपने को. हाँ सही बोल रहा है. ये करंट इज इक्वल टू ना नोड होगा. अगर नोड होगा तो चलेगा क्या?
करंट इज इक्वल टू करंट डॉट राइट भी कर सकते हैं. और जैसे हमने
करंट इज
ऊपर
इक्वल टू
करंट.
करंट डॉट राइट अगर करेंगे तो 13 के बाद जब हम यहाँ पे आ गए तो ये तो नन हो गया. ठीक
पर
है.
इस समय करंट हमारा 15 आना चाहिए.
हाँ लेकिन नहीं है ना 15.
हम्म,
रुकिए रुकिए, मैं इसको फिर से स्टार्ट करते हैं. मैं भी अभी मुझे भी याद नहीं है. मैं भी अभी सोच के ही कर रहा हूँ. एक मिनट, फिर से स्टार्ट करते हैं. ठीक है. 8 15 16 ये यहाँ तक तो आ गए. 8 15 एंड 13. आफ्टर दिस कोड हैज रन, व्हाट इज करंट? करंट इज हियर, none. While current, okay, current is equal to current dot left, so we kept going and we reached the none here. Correct? That is that clear? And then we did a node is equal to stack dot pop, so we took out 13 and we appended 13 here. Okay, and then I wanted to go from 13 to 15, so what I wrote here was current is equal to current dot right. Current is equal to current dot right. But will this line of code work? Somebody pointed out correctly. Will this line of code work? No, because current is none. So I want to go from 13 to 15. So 15 is not current dot right. 15 is node dot right. अब हो जाएगा. Thank you, whoever pointed out. Node dot right. So where is node? What is node? Node is 13. So 13. करंट कहाँ पे है? नोड इज इक्वल टू स्टैक डॉट पॉप.
स्टेक से हम जब पॉप करेंगे
हाँ हाँ.
तो ऑलरेडी करंट चेंज हो जाएगा, राइट? हम
कहाँ
ऐड
पे?
करेंगे इधर रिजल्ट में, रिजल्ट डॉट अपेंड
रिजल्ट डॉट अपेंड.
और स्टेक डॉट पॉप ये किए आपका
नोड डॉट वैल्यू कर दिए. ठीक है, उसके बाद
नोड डॉट वैल्यू. तो अब जो करंट वैल्यू निकालेंगे ना तो
हम्म.
स्टेक का जो टॉप में रहेगा
हाँ हाँ.
विल बी करंट, राइट?
ये बात तो सही है कि हाँ नोड डॉट राइट होगा, बट मैं ये सोच रहा हूँ कि 13 का राइट तो नहीं है ना. 15 का राइट 13 है. 13 का राइट कुछ भी नहीं है. हाँ नहीं नहीं, सही है. हो गया
करंट फिर
ये
भी नन हो
100%.
जाएगा.
ये 100% करेक्ट है. हो गया. सॉरी.
ये चलेगा.
ये 100% चलेगा क्योंकि 13 का राइट नहीं है. करंट इज इक्वल टू नोड डॉट राइट. तो 13 का राइट कुछ नहीं है. तो 13 का राइट तो प्रोसेस तो करना है ना. वी वांट टू प्रोसेस द राइट ऑफ 13. इट इज नन. ओके, सो करंट बिकम्स नन.
लूप
सो
लूप
दिस
से बाहर आ जाएगा ना सर?
लूप से बाहर आ जाएगा. नेक्स्ट टाइम वी विल गो एंड वी विल फाइंड स्टैक. सो स्टैक में हमें वैल्यू मिल जाएगा ना 15. सो नेक्स्ट टाइम नोड का वैल्यू इज 15. रिजल्ट डॉट अपेंड 15. देन करंट इज इक्वल टू नोड डॉट राइट. 15 का राइट 7. Again we will go while current. So now we have to iterate 7. So same process will happen. We'll go 7 dot right, 7 का left जाएंगे. So pattern is beautiful. This is going to work. Did you guys understand?
Yes.
Sorry, I got confused a little bit.
So node dot right means 7 is indicating 7, right? 7 and 13.
Wait. I will explain one more time. But I hope some of you got it.
Yeah.
I'm happy to see that all of you are able to get it. Okay. Okay. See, the pattern has to build. Now you see, now the pattern will come nicely. 8, 15, 20, 13, 7, 50. See, unless you do it in a pen and paper, you will not remember. See what will happen now. What is the pattern? Remember the pattern. We will start from here and we'll go left. Till where? Up till a point where we reach none. So here we have reached none. And we have reached none. So 13 is done. After 13 is done, we'll go to 15. Then we'll go to 7. And again, we will follow the same pattern. We'll go left. Okay, now you see how that this code is simulating that. You see, we'll start with a stack and we'll start with the result. Okay, one more time I'm explaining. Okay, so you see, it says result is null, result is empty list, fine, stack is empty, fine, current is equal to root, current is here. Okay, current is here. Keep in mind, we are starting with current on this node and we are doing a DFS. So current can be here also, current can be here also, current can be here also. So every node will get a chance to become the current node. So whenever a node is current node, the same pattern will follow because it is kind of repetitive. Okay, so it is saying while stack or current, while current, stack dot append current. So if our current node is here, we'll go like this and like this. So we'll go 8, 15 and 13. So we are processing now 13, which is the leftmost node of the root node. Whichever was the current, uska sabse leftmost node traversing from that left, we are reaching 13. Okay, so we have to process 13. We will pop 13. We will append 13. Okay, and we will try to check the right node of this. Left node to null ho gaya. That's how this loop started. Then we will check the right of this. Current is equal to current dot right. If it is none, okay, if there was some value, then what would have happened? This code would have gone left of that also, but that is not there. So, okay, this is the most beautiful thing. Okay, then while current is none, this will not work. Okay, this whole thing is gone. Again, we will come here. Our current is now null. So we will look at stack. This 13 is done. Okay, and we will take out 15. So 13 ke badle now 15 will come out. Okay, now we have node. This is 15. Result dot append node dot value, which is 15. And then it is saying current becomes node dot write. So current is now node dot write 7. So initially current was here, not here. We traversed and checked 13. Then we checked the none of this. So this got to be current. This got a chance to be current. And then 13 job was done. 15 job was done. Now current is at 7. So we need to traverse the entire tree of 7. But both are null. So nothing will happen. Okay. So we will put 7 and we will come back. Then what is the next current? 15 will be done. Then what is the next current? 8 is the next current. Did you understand, guys?
Yeah.
Do a dry run of this. Do a dry run of this. You see, recursive code was so simple, no? But this is slightly tricky. What is the time and space complexity, by the way?
Time and space complexity. I think we need to iterate all the things, right?
You are visiting all the nodes. So usually when we are traversing, we are visiting all the nodes. What is the space complexity?
O of 1 only, space. Each
Why
space,
O of 1?
no?
You are using this stack.
O of n raised to 2.
O of n, okay.
So we are using result as well, right? And one stack as well.
See, result is not counting because result is you have to return the result. So it is a demand of the question.
Okay.
And stack we are using. So stack is taking O of n. Okay, so time and space complexity both is O of n. Even if you are counting this, then it becomes O of 2n, which is also O of n only. But what we are supposed to return, that we don't count.
वो अब वेन होगा या बिकॉज 2 while लूप लगा है इसमें
2 while लूप लगा है लेकिन देखिए इसीलिए मैंने कहा था कि ये दिमाग में ये लॉजिक मत रखो कि 2 नेस्टेड लूप है तो वो ऑफ एन स्क्वायर्ड होगा 2 नेस्टेड लूप होगा तो कुछ भी हो सकता है। आप कोड वाइज देखो कि आप क्या कर रहे हो। आप 8 से निकले 15 पे गए 13 पे गए फिर ये नोट सारा चेक किया ये नोट चेक किया फिर 15 पे गए फिर 7 पे गए तो आप सारे नोट को विजिट करो। इफ देयर आर n नोड्स यू विल डू n ऑपरेशंस। Space complexity worst case O of n है। When it will be O of n? When will all the nodes be in the stack? Can someone tell me?
When all the nodes are left.
Left.
All of them are left when it is a skewed tree. Okay, this is a iterative solution. Iterative in order traversal.
So if you make, okay, this is a binary tree, right? Okay, that's good. So can you make it one more leaves, right?
One more leaves means?
So one 13, 14, 15, you can add one more things, no? The bottom level 3, level 4.
Add how much ever you want.
Then do we need to change the
Return
logic?
सेम है ना,
Because
तो रिटर्न में कितने भी ऐड करो वो चलेगा.
we are updating the logic current dot left, right? So can we make it current dot left like
The
this?
code is not going to change. You can add as many number of trees or as many number of leaves or branches here. The code is going to be the same.
But right, but when we iterating the inner while loop, right, we are navigating only the two paths, right? Current dot left.
So it is current equals to current dot left.
Or current equal to dot current. Current dot current equal dot current dot left.
Current dot left is making no sense. No, this is like this.
Yeah, that's why I have confusion. Right.
Okay, try to write this. Otherwise, I think we have already written the in order traversal. Try to write it on your own. I will not go into it. Okay.
Okay.
Let us finally do post order traversal and then we will do some other questions. So if we want to do post order traversal, then if we do the easy one, which is recursive,
It
then it's
is
very simple, no?
left, right, and
Just
okay.
we have to switch the statements. Correct?
Yeah, make it left, right, and
So we'll write the same code. We'll say stack, not stack, sorry. Result. And then DFS node. We'll say if not node, return. Otherwise, we'll do first what?
left.
First
DFS.
left. We'll do DFS of left.
Then DFS of right.
DFS of right.
Then append.
Then result dot.
Result dot append. Node dot data or value.
Okay, and then we will call DFS of root. And we will
return the result.
One second, guys. नहीं है 686616 686616. Okay, DFS of root and then
return the value.
Return result. Okay, can we try this out? Till then, guys, help me with the iterative approach. I will quickly write the code. I will do the easy work. You do the difficult work. Post order. DFS of left, DFS of right, and then
And the
equal
result
dot
value.
append node dot val return.
But before that, the DFS of root.
ठीक है?
Yes.
How will we do the iterative solution of this one?
First left side.
Can you put the graph means line numbers so that we can put dry run and for the iterative? Yeah, if you keep that.
Same left side. That.
What we have to do? See,
It will be okay.
first we have
Left,
to
right, and
do
center. Yeah.
first we have to do left, then right, then we have to go to center.
Yeah.
Okay. So if we start from root, okay, and if we put it in a stack, okay, suppose we put 8, okay, then we put
Then 13.
so we have to do 8, but before doing 8 we have to do 15. Correct?
Yeah.
No? So somewhere we have to take out this 8, put it somewhere, process children of 8, then go back to 8.
Yes.
Do you guys agree?
One second, sir.
Final result 13.
Final
7.
result. Let us do final result. Okay.
Yeah,
fine.
yeah. Then will be easy.
It will be 13,
7.
7,
Left, right.
15,
15. 8.
8,
8 to
15,
20.
20. But if you see in terms of pattern, like we are going to use a stack that we know. Okay. But how will we do? I'm thinking that we'll have to do some kind of pushing and popping. Okay. Because we have 8. We can put 8 here. But we don't want to process 8. Do you guys agree? We want to process 15 and 20. Then we want to process 8. So can we take another stack? Put 8 here.
8 should come in the last one.
8 should come in the last.
Yeah.
वही मैं बोल रहा हूँ कि 8. But when we are starting, we'll start from the root.
No, in the answer also,
But,
like 13.7.
Okay. Thirteen, 7, 15. 15, let me make this 5. This will be 5. Right is nothing, 20, and then 8. Okay. So what we want, so when we start, are you guys following my line of thinking? That when we start from 8, we have 8, we can put 8 in the stack. Suppose this is our stack. Main. Suppose this is our main stack. We have done patterns where we are using 2 stacks, right? So we can put 8 here, but 8 we don't want to process. So can we take out 8 and put it in some other stack? Okay, let me call this help. And then I want to check which are the children of 8.
15 we have to go. Yeah.
15 and 20. So can I put 15 here? I'm just thinking how it will be. I've also forgotten. So 15 and
No, 15 only have to go first, right? Left side.
but I want to put 20 also because we have to process later. Left 15 and 20. Now we can process 15. Does it make sense? Guys, please tell me in the chat.
20, 15, 15,
सर
20.
8 भी तो फिर 20 के नीचे रह सकता है. Why would we need a different step?
8 भी
20, मतलब if you put 8 first in the main stack, so it will be at the bottom of the stack, right?
बॉटम ऑफ द स्टैक, ठीक है.
And then जैसे अभी आपने उसके ऊपर 20 डाला, यानी आपने रूट डॉट राइट किया होगा, मे बी
हाँ
बिकॉज स्टैक में जाना है इसलिए.
हाँ
एंड देन आपने रूट डॉट लेफ्ट किया है एंड यू वेंट
हाँ
टिल 15 नाउ.
हाँ.
तो अभी आप 15 कॉप कर रहे हो और 15 के चाइल्ड विजिट कर रहे हैं, राइट? सो उस हिसाब से फिर मेन स्टैक में 8 सबसे लास्ट रहेगा, तो वो वैसे भी लास्ट प्रोसेस होगा, राइट? तब तक उसके ऑलरेडी लेफ्ट और राइट सब ट्रीज विजिटेड होंगे एंड 8 विल बी एट द बॉटम. सो नो नीड ऑफ हेल्पिंग स्टैक इन दैट केस.
जो जो सीक्वेंस में रीड करेंगे, जिस सीक्वेंस में उसमें पुट करते जाएंगे, एट्थ लास्ट में ये आएगा.
8 लास्ट में आएगा, वो बात ठीक है, लेकिन वो ऑर्डर फॉलो नहीं होगा अगर आप 8 को इधर रखोगे ना. करके देखते हैं.
नहीं, आप पुट कर रहे हो, फर्स्ट 8 को पुट किए.
वो मैं समझ गया आपकी बात को. अगर 8 यहाँ पे रखे रहते आप, यहाँ पे
हाँ,
15 डाल देते, यहाँ पे 20 डाल देते, तो भी तो
20 डाल
20
दो.
पहले ही आता. तो 8 को यहाँ
हाँ,
रख के क्या फायदा, ये बोल रहे हो ना आप?
राइट.
हाँ, वो मैं समझ गया. हम्म. मैं जो बताना चाह रहा हूँ ना, वो ये है कि 8 अगर हम इसको यहाँ डाल देते हैं, ठीक है. फिर 8 को हम प्रोसेस करना चाहते हैं, ठीक है. वी वांट टू प्रोसेस.
பேட்ல எச்சு போட்டு அது ஸ்லிப்ல நின்று இருந்த சச்சின் டெண்டுல்கருக்கு கேட்சா மாதிரி இருக்கும். சச்சின் டெண்டுல்கர் கேட்சை எடுத்திருப்பாரு. நீங்களே யோசிச்சு பாருங்க, ஒரு பால் ஆனது பிச் ஆகி ஸ்லிப்ல.
Ramesh, can you mute here?
हाँ, इट्स ओके. वी वांट टू प्रोसेस 8, ठीक है. चलो, when we want to process 8, what is the meaning of processing 8?
That means now we have to check for its right child and left
We
child.
want to process the left, 8 dot left, and we want to process 8 dot right. It's okay. Understanding? So we want to process 8 and we want to process 8 dot left and 8 dot right. 8 dot left को process करने के लिए again we have to process 8 dot left, which is 15. We want to process 8 dot
13, right?
we want to process 13 I'm just trying to think that how it will come in the stack. So it will process 7. ठीक है, तो ये 8 को प्रोसेस करेंगे. 8 को प्रोसेस करने के लिए स्वैप तो करना पड़ेगा हमें. Let us push 15 and 20 here.
Sir, your first
Okay.
order was right. 20 needs to be
See,
below.
why we have to remove it is because we have to keep track of when we have finished the children of it. I don't know how to explain it, but you have to keep track of how you will finish the 2 children. For
ठीक
that,
है,
one stack
ठीक
has
है
to be
ना.
empty.
8 code and
We have to
50.
keep track. We have to keep track of when this stack gets empty.
तो अभी
Because when this
30
stack
7
gets
पुट करेंगे ना,
empty,
उसके बाद फिर चेक करेंगे.
when this stack gets empty, then only we want to process 8. Okay,
हाँ,
so
बट
you see
अभी
the pattern. What I'm trying to say, I don't know if I'm able to explain it correctly, but see, when I put 8, okay, why I want to put it here is because I want to pop 8 when this 15 and 20 are processed. Okay, if I want to process 20, okay, then in order to process 20, I will process 20 only when I don't have the code. Okay, I don't have the solution, but I'm just thinking that I want to process 20 when 5 has finished.
तो अभी अभी अगेन
हम्म
इसमें आपने 15 इसमें लेफ्ट है, 20 एंड 8 है. ठीक है, 28 ठीक है, 8 एंड 20 जो आपका हेल्पर है.
15-20
अभी
होगा, 20-15 होगा, मुझे मालूम नहीं अभी, बट मान लीजिए 15-20 है. लेफ्ट और राइट हमने डाल दिया, यहाँ पे 8 है.
हाँ 8. सो अब इसमें 20 और 15 को फिर इसमें पुट करेंगे. इसमें 13 और 7 जाएगा आपका मेन स्टेक में.
हाँ,
अब यहाँ पर चेक करेंगे कि 13 और 7 का हमारे पास में लेफ्ट राइट नहीं है उसका.
नहीं है.
ठीक है, तो उसको प्रोसेस कर देंगे.
हम्म
और यहाँ का जो आपका रहेगा 15 और 20
हम्म
हेल्पर पे, वो फिर हम लेफ्ट में पुट कर देंगे. मेन
फिर से
मेन
बताना, फिर से बोलो.
15 एंड 20 हेल्पर स्टेक में 8 8
एक
15
मिनट,
20
सॉरी,
होगा.
फिर से, हाँ, फिर से बोलो.
हेल्पर में 8
हेल्पर में
15
8,
20.
उसके बाद यहाँ पे 15 और 20 डाल दिया. ठीक है.
हाँ नहीं हेल्पर में 15 एंड 20.
हाँ,
15 और 20 को निकाल के इसमें डालिए ना हेल्पर में.
15 और 20 को दोनों को निकाल के हेल्पर में डाल देंगे.
हाँ
ठीक है.
हाँ. अब जो इसका 15 का लेफ्ट और राइट अवेलेबल है, तो 13 एंड 7 को इसमें
15
पुट.
कैसे ट्रैक होगा जब दोनों निकाल दिया, तो 15 का ट्रैक कैसे रखेंगे? अच्छा, लास्ट वाला वैल्यू, तो फिर 20 किधर जाएगा?
Sir, I'm just thinking out loud now. हम
हाँ, टेल
पहले
मी.
करंट 8 पे रखेंगे, राइट? एंड देन
करेंट 8
फर्स्ट
पे,
विल विजिट.
एक मिनट,
हाँ,
करंट
एंड
8 पे है. ठीक है, यहाँ से
राइट,
हटा देता
वो
हूँ मैं.
स्टैक,
हाँ,
वो मेन स्टैक में गया. ठीक है, बिकॉज
8 मेन स्टैक
क्यों?
में गया.
बिकॉज
ठीक है.
क्योंकि अभी तक उसके पास दोनों चाइल्ड है अवेलेबल, दोनों साइड के, राइट? उसके
ठीक है.
बाद वो फर्स्ट विजिट करेगा राइट चाइल्ड के पास, सो दैट वी कैन पुट 20 इन द स्टैक. राइट
20
पहले विजिट करेगा, 8 का राइट.
राइट
तो इट
पहले
हैज
विजिट
राइट
करेगा.
चाइल्ड. हाँ, इट
ठीक है,
हैज राइट चाइल्ड, इसे 20 गया. नाउ
20
8
जाएगा.
का सेकंड लेफ्ट चाइल्ड इज 15, तो 15 भी है. ठीक है, तो नाउ अभी आप 15 के ऊपर हो, राइट? नाउ
15 के ऊपर हो.
इस
ठीक है,
15 के
15
चेक
इसमें डाल
करेंगे.
दूं.
यस, बिकॉज यू, हाँ,
ठीक है.
अभी 15 का वापस, बिकॉज यू स्टिल हैव राइट एंड लेफ्ट चाइल्ड फॉर 15, तो 15 का राइट चाइल्ड चेक होगा विच इज 7. 7
7.
वापस जाएगा.
ठीक
एंड
है,
देन 13 भी जाएगा,
तो
बिकॉज
रिजल्ट
13
में,
उसका लेफ्ट.
ठीक है, 7 जाएगा, उसके बाद 13 जाएगा. ठीक है.
13 जाएगा बिकॉज लेफ्ट. हाँ, मैं उल्टा करी, बिकॉज अपने को उल्टा निकालना होता है, राइट? तो
ठीक
डालते
है,
हाँ.
ठीक है. ठीक है. ठीक
अभी
है.
13 का राइट चाइल्ड भी नहीं है, लेफ्ट चाइल्ड भी नहीं है,
ठीक है.
राइट? तो ये
ठीक
बन
है.
गया आपका फर्स्ट रिजल्ट में जाएगा, रिजल्ट लिस्ट में. ये मैं
रिजल्ट
हेल्पर
लिस्ट में.
स्टैक नहीं सोच रही हूँ. हाँ,
नहीं,
तो
ठीक
दैट
है,
इज
ठीक है,
योर
आप जो बोल
13.
रहे हो सही है. ये 13 चला गया, तो 13 को यहाँ
13
से मैंने पॉप
ना,
कर दिया.
पॉप कर लिया, यस.
ठीक है.
नाउ मेरा पास स्टैक का टॉप क्या है? 7.
स्टैक
7,
का टॉप है
राइट?
7. ठीक है.
7 का वापस मैंने चेक किया, लेफ्ट राइट चाइल्ड है या
अच्छा,
नहीं, एंड
चाइल्ड
लेफ्ट
है नहीं
चाइल्ड है
तो
या
ये भी
नहीं,
चला
ओके,
जाएगा.
लेफ्ट राइट चाइल्ड वी डोंट हैव. ओके,
तो 7
बिकॉज
चला
इट इज
जाएगा
नॉट राइट.
रिजल्ट में.
गाइस प्लीज,
हाँ,
वन पर्सन एट ए टाइम. हाँ,
तो
लेफ्ट एंड
इसमें
राइट
दोनों
चाइल्ड नहीं है.
चाइल्ड नहीं है.
ओके, Okay.
Exactly, again pop this now because it doesn't have any more task. हाँ,
Okay.
अभी मैं वापस 15 के पास जाऊंगी.
15 के
15
पास
के
जाए.
दोनों चाइल्ड मैंने बोला है, मैंने विजिट कर लिए, राइट?
ये कैसे पता चलेगा कि दोनों चाइल्ड विजिट कर लिया? हाँ ठीक है, क्योंकि जब आपने ट्रैवर्स किया तो आपने विजिट कर लिया था.
हाँ
ओके
हाँ, तो
ठीक
मैंने
है.
विजिट कर लिया, तो 15
हाँ
का भी काम हो गया बिकॉज के दोनों चाइल्ड विजिट 15 आया.
ठीक है.
अभी मेरे पास 20 है, तो 20 के चाइल्ड विजिटेड नहीं थे. अभी इसका लॉजिक सोचना पड़ेगा. आई एम जस्ट थिंकिंग आउट लाउड इज व्हाट आई टोल्ड यू, राइट? So now I'll now go to 20's right child, which I don't have anything. Again, I have
तो
5.
20 को
So I'll
हेल्पर में डाल देते हैं ना, 20
हाँ
को
बट
हेल्पर में डालते हैं.
हाँ करेक्ट, बट यू विल नॉट नो. यू हैव डन वन साइड,
hmm.
but you will not know that, you will not be able to keep track of the right one, that where it has ended.
स्टैक चाहिए सर इसको सॉल्व
हाँ
करने के लिए. 2
Okay.
स्टैक चाहिए.
दो स्टैक का इंट्यूशन मुझे क्यों आया है वो मैं बताता हूँ. दो स्टैक का इंट्यूशन मुझे इसलिए आया है, व्हाई आई एम थिंकिंग अबाउट टू. आई डोंट नो वेदर टू स्टैक विल बी यूज्ड और नॉट, but this is coming to my mind because my logic was that I have to process 8. Okay, and in order to process 8, I will process 8 only when 8 dot left and 8 dot right are done. So I am thinking that I will put somewhere 8 here. I'm thinking loud. 8 I will put here, and I will put the children here. When the children are completed, then I will put 8. Then I will take out 8. That is my thinking.
तब तो 8 का, जब तक मैंने पूरा लेफ्ट एंड राइट पूरा खत्म होने पर ही हमको 8 को निकालना पड़ेगा. तब तक 8 है वहीं पे रहेगा.
नहीं, इसमें
बिकॉज
पोस्ट
दैट इज
पोस्ट
द
आ रहा था
रिजल्ट,
ना.
राइट? फाइनल रिजल्ट इज 8. लास्ट पॉप वाला 8 ही रहना चाहिए.
ठीक है,
5,
बताओ अप्रोच बताओ कोई.
5, 20, then 8.
मैं तो भूल गया हूँ, मुझे तो ये ऑनेस्टली याद नहीं. अभी अभी मुझे समझ में भी नहीं आ रहा. बट समवन टेल मी, हेल्प मी इफ पॉसिबल.
बट अगर सेम में ही हम करें, जैसे इसको करने के बाद में हम इधर आ जाते हैं, जैसे इसका पूरा फिनिश हो गया, अभी 8 बाकी है. ठीक है, 8 अभी बाकी है. बट इसका हम यहाँ पर 15 को पुट कर दिए, तो लास्ट स्टेक में 8 था. अब इसका हम राइट लेफ्ट ट्रेवर्स किए हैं, राइट ट्रेवर्स बाकी है ना, तो राइट का हम ट्रेवर्स करेंगे 25 का.
ट्रैवर्स करेंगे, बट वो पता कैसे चलेगा कि वो ट्रैवर्स नहीं हुआ है? बिकॉज व्हेन यू स्टार्टेड यू डिड लेफ्ट 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 लेफ्ट, राइट यू हैव नॉट ट्रैवर्स्ड. What she said, that is the closest approach, that is the closest solution. Okay, but where she got stuck was that she did left left left, but she did not forget to do right. So in order to split that right and left portion only, I'm thinking of 2 stacks.
बट लेफ्ट जो मेन स्टेक है, मेन स्टेक में तो 8 बचा है, तो 8 का हम लेफ्ट से तो कर ही चुके. अब हमें
फिर
राइट
से
को ही
करते हैं,
करना है ना.
फिर से करते हैं. मेन स्टैक में मैंने 8 को डाल दिया, ठीक है. फिर 8 को
हम्म.
मैंने निकाला, ठीक है, इसमें डाल दिया प्रोसेस करने के लिए. और 8 को प्रोसेस करने के लिए मैंने यहाँ पे 15 और 20 डाल दिया, ठीक है. इसके बाद मैंने रिजल्ट में 15 और 20, 15 और 20 मैंने डाल दिया. रूट डाल दिया, स्टैक 1. 20 को निकाला, 15 को नहीं याद आ रहा यार, नहीं समझ में आ रहा, मुझे देखना पड़ेगा. Let us take 10 minutes break. My mind is also not working. Okay, I will also think. I need time to think. 10 minutes. Okay, we'll take a break. We'll be back at 6:18. You guys also think. Okay,
6:20, sir.
6:20. Okay, fine.
Yeah. Sir, and one more question just I wanted to ask, too curious. So for this linear, it is efficient memory storage than tree structure, non-linear memory computing level. So how is
See,
the
I've told
memory?
many times that efficiency and all depends on what you're trying to do. You have to first define that what you're trying to do.
Correct, but let us take in each node, right? Each node, it has the reference of that next, no, left and right node, right? In binary tree. So
What you are
it is a
trying to
whole.
achieve, those are two very different things.
Mhm.
Those are
Yeah,
two very
mostly.
different things. What you are trying, what you will achieve using a tree, the same thing you cannot achieve using an array. So how can you compare it?
Yeah, right. It is a hierarchical structure.
Exactly.
Correct. It's a different use case, but
How
my
can you
question is
compare the
that.
cost of travel
Hmm,
using a taxi and cost of travel using a plane? Both are
okay.
different, no?
Yeah.
You can compare the price of Ola and Uber, but you cannot compare price of Ola with Air India.
Hmm. Okay.
You can
So
compare array and linked list for certain application where both can be used.
okay.
That you can do. You can compare the traversal, that if you do DFS versus BFS, which one is more efficient? That you can do. But if you compare graph and array, it is those are different things.
Okay. Got it.
Just give me some time. Let me think.
Okay. Take your time.
Uh, See guys, I got it. Okay. Anyone is there? See what we have to do.
Yes, sir.
क्या करना है देखो.
मेरे को भी ऐसा लग रहा है 2 स्टैक लेना पड़ेगा
8 डाला
पहले।
यहाँ पे. ठीक
हाँ,
है.
पहले 8 के जाना
फिर
पड़ेगा
8 को
फिर।
प्रोसेस करेंगे.
हाँ
8 लास्ट में जाएगा. 8 के जो चिल्ड्रन है 15 और
हाँ
20
15 और 20, हाँ।
उसको डाल देंगे. ठीक है.
फिर 20 का देखेंगे और 20 को फिर भी इस तरह पुश करना पड़ेगा।
फिर 20 को यहाँ से हटा देंगे.
हाँ, इसको
20
राइट
के
राइट मोस्ट
चिल्ड्रन
है
को
ना।
यहाँ
हाँ
डाल देंगे.
हाँ हाँ।
ये देखो 8 और 20 यहाँ पे आ गया. ठीक है. फिर हमें 5 चाहिए तो देखो 5 यहाँ आ गया.
हाँ
ठीक है. और फिर 5 के 5 आ गया तो फिर 15 बच गया. ठीक है. उल्टे वी आर गोइंग रिवर्स. 15 देन 15. But this is bad. Okay, I'm just doing जुगाड़, reverse engineering. 15.
नहीं ना, बट हाँ फाइनली हमको ना हेल्पर 2 को पॉप करने से पूरा पूरा वैल्यू आ जाएगा
बट
सर करेक्ट
इंट्यूशन
टाइम
नहीं
पे।
आ रहा है ना इसका कि ऐसा क्यों कर रहे हैं. इसका पैटर्न नहीं बन रहा है ना. इंट्यूशन नहीं आ रहा है. 15 आ गया. ठीक है. मतलब ये अभी क्लिक कर गया. अभी कभी और पूछेंगे तो क्लिक नहीं करेगा. 15 आया तो 15 डाल दिया. यहाँ पे दिख रहा है हमको पैटर्न उल्टा बन रहा है. 15 और 15 के चिल्ड्रन है यहाँ पे 13 एंड 7. फिर 7 को पॉप किया, 7 डाल दिया. देखो यहाँ पे 7 है. और फिर 13 को पॉप किया, यहाँ 13 डाल दिया. फिर यहाँ 13 आ गया. 13
रिवर्स पॉप करेगा तो हो गया रिजल्ट। हाँ
हाँ. बट पता नहीं, मुझे कन्विंसिंग नहीं लग रहा है. इसका कोई दूसरा अप्रोच होगा जो मुझे याद नहीं आ रहा है. मैं बाद में बताता हूँ. या देखता हूँ मैंने पहले सॉल्व किया है क्या इसको. पोस्ट ऑडिटर ये भी रिकर्सिव किया था मैंने. स्टैक डॉट पॉप करंट डॉट लेफ्ट. हाँ. स्टैक रूट इज नन. स्टैक डॉट अपेंड रूट. इफ नॉट रूट इज नन.
लेफ्ट राइट ऐसे ही किया सर आपने।
हाँ लेकिन स्टैक नहीं लिया था मैंने.
बट फाइनली आपने माइनस कर दिया रिजल्ट, रिवर्स ऑर्डर में डाल
लिस्ट
दिया।
को रिवर्स कर दिया. स्टैक को लिस्ट ही लिया था कैसे कि
हाँ तो यहाँ पे एक ही लिया आपने, ठीक है।
करंट एक ही लिया. करंट इज इक्वल टू स्टैक डॉट पॉप रेस डॉट अपेंड. करंट स्टैक डॉट अपेंड. इसको देखते हैं अब मैंने क्या किया. मैं एकदम मेरे दिमाग से निकल गया ये क्या है. ठीक है. एक रिजल्ट लिया मैंने. स्टैक लिया.
आपने फाइनल वैल्यू को
while stack. So if not root is none. If not, क्या गंदा कोड लिखा है मैंने. देखो if not root is none. root is not none. Then stack dot append root. ठीक है. कौन सा एग्जांपल कर रहे थे हम लोग. यहाँ पे मैं ड्रॉ कर लेता हूँ. 8 15 20 13 7 5 suppose. Will current is equal to stack dot pop. Current is equal to stack dot pop. Stack में है 8. Okay, so we'll take out 8. Result dot append 8. Okay. If current dot left 15, then put 15. If current dot right,
बट यहाँ पे देखिए सर, यहाँ पर फिर से आपने करंट और लेफ्ट को ही अपेंड किया ना आपने.
current dot left को append किया. ठीक है. current dot left, current dot right is 20. Fine. Stack dot append. Sorry, not result. Stack dot append. Stack dot append 15 and 20. Okay. Then we took out 15. Result dot append 15. 15 dot left and right. So I'm putting 13 and 7. फिर से result and stack. Okay. Stack is having 8. Stack dot append. Current is equal to stack dot pop. Current is equal to 8. Stack से हटा दिया. result dot append current dot value 8, stack dot append current dot left and right, so 15 and 20. Then again we will pop. Okay, we will pop, so we'll pop 20. Sorry, I was popping from the front.
हाँ 20 को करोगे हाँ
20, हाँ ठीक है. 20 dot left and 20 dot right, so result में 20 and 20 का left and right, which is 5 and nothing. Okay, then we'll take out 15. We'll put 15 and then we'll put 15 का left and right, which is 13 and 7.
7 का ऐड करोगे हाँ
ठीक है, उसके बाद क्या करेंगे?
पॉप करेंगे पहले लेफ्ट का
7 पॉप करेंगे.
नहीं 13 पॉप करेंगे ना
13 कैसे पॉप होगा?
पहले
13
करंट डॉट लेफ्ट स्टैक डॉट अपेंड किया ओके ओके पॉप कर रहे हो करंट का सबसे
आंसर,
ऊपर
इसका
वाला
आंसर क्या है? 13 5 13 15 7 13 15 7 5 20 and
28 तो रिवर्स में ऑर्डर में आ रहा है ना सर
हाँ
820 आगे 15 आगे 825 वो क्या 5 आना चाहिए ना
रिजल्ट में 8 लेफ्ट एंड राइट. फिर से करते हैं, कुछ मिस्टेक हो रहा है. This is correct, no? This is correct. This one is again, let us do. Stack dot append root. Stack dot append root. Okay. Res dot append current, इसको pop कर दिया. Current is equal to 8. Result dot append current dot value 8. Okay. 8 is here, no problem. If current dot left, stack dot append current dot left 15 and 20.
हाँ फिर 20 को पॉप करोगे हाँ
20 को पॉप करो, मैं 15 को पॉप करा था शायद. ठीक है,
हाँ
so
20
this
को
is
pop
done. Then we will append 20. Again I was doing the same mistake.
20 हाँ हाँ राइट का हो जाएगा
20 यहाँ डालेंगे. ठीक है, 20 को यहाँ से पॉप कर दिया, 20 डालेंगे एंड देन 20 के चिल्ड्रन को डालेंगे यहाँ पे 5.
हाँ 5 को ऐड करेंगे स्टैक पे हाँ
फिर पॉप करेंगे 5 को
5 को स्टैक कर दे तो ऐड कर देंगे रिजल्ट का
यहाँ
ऐड
पे
कर देंगे
5
5
डालेंगे.
हाँ
5 का चिल्ड्रन नहीं है. ओके,
हाँ
तो 5 यहाँ से पॉप हो गया. देन वी विल पॉप 15.
हाँ
15 के चिल्ड्रन 13 and 7 will go here. Okay, then we will pop and 15 we will put here.
नहीं 7 आ गया ना 7 आएगा
यहाँ पे भी तो डालना है ना 28 25. अच्छा अब 7 आएगा.
7 आ जाएगा ना ऊपर है ना सबसे ऊपर
तो यहाँ पे 7 डालेंगे. 7 के चिल्ड्रन नहीं है कोई भी. 7 यहाँ से
तो
पॉप हो गया. फिर
15
13 निकालेंगे.
हाँ 15 को ऐड करते हैं
13 निकालेंगे. 15 कैसे निकालेंगे? 13 आ गया क्या?
नहीं 13 लास्ट में आएगा ना
13 लास्ट
13 इज लेफ्ट
पॉप
लेफ्ट
कर
सब
रहे हैं ना. नहीं, राइट से पॉप कर रहे हैं ना.
हाँ तो राइट का वो पॉप माने 15 13
is
will be
also
last
there,
form
13 15 13 and 7. 13 will come, no? 13
13 लास्ट आएगा क्योंकि 13 का राइट 7 आना चाहिए ना 7 तो आ गया फिर बाद में 15
कहीं पे मिस्टेक करो बट दिस विल वर्क.
हाँ दिस लॉजिक विल वर्क
वो मैं कहीं पे गलत निकाल रहा हूँ. फिर से एक बार करते हैं. एक्चुअली वो 2 स्टैक वाला अप्रोच इज नॉट नीडेड. दिस इससे काम हो जाएगा. स्टैक इज 8. ओके, 8 को पॉप किया,
8 का ऐड किया रिजल्ट में
8.
हाँ
8
रिजल्ट
के
ऐड कर
चिल्ड्रन 15 and 20. 15 and 20. ओके, एंड 8 को यहाँ डाल दिया. फिर 15 को पॉप किया. ओके, 15 को यहाँ सॉरी अगेन
20 को पॉप किया
अगेन आई एम मेकिंग द सेम मिस्टेक. माय माइंड
हाँ 20 राइट इज द हाईएस्ट ऑफ द
राइट को पॉप करना है ना. वी
हाँ
पॉप
राइट इज द
20.
हाईएस्ट हाँ टॉप ऑफ द
20 we will pop. Okay.
हाँ
20
का
will
कर
put 20 will put here.
हाँ
Then 20 का चिल्ड्रन 5
5 है 5 को ऐड कर दीजिए
5 को ऐड करेंगे.
स्टैक का हाँ
Then we'll
5
take
का
out 5.
एंड
5
5
we will
ऐड
put here.
हाँ
5 का चिल्ड्रन is nothing, so 5 is
तो 5
popped.
निकल गया
Then we
अब
will pop
15.
15. Okay, 15 I forgot to remove. So we'll take out 15.
15 का चाइल्ड भी ऐड करना पड़ेगा। हाँ
15.
स्टैक।
So 15 we'll have to add here, no?
हाँ बट इसके पहले 15 का राइट को ऐड कर, लेफ्ट का ऐड
15
करो, राइट को ऐड करो। 13 and
हाँ,
7
तो
you have to
15 का children is 13 and 7,
7 हाँ
but
अभी
we'll have
हो
to add 15 here, but that will not work. 8 25 ये सही है ना? 13 7, this is wrong actually. ये आंसर ही wrong है, that's why we are getting it wrong. It is 13 7 then 15, correct? 13
हाँ
7 and then 15,
हाँ लेफ्ट राइट एंड रूट हाँ
and then 5 20 and 8. This was wrong. Now we are getting it correctly. Now it is correct. I got it.
लास्ट में लेफ्ट वाला हो चाहिए क्योंकि हम लोग राइट से पॉप कर रहे हैं ना,
राइट
so
से
we
पॉप
should-
कर रहे हैं, वो हो
हाँ,
जाएगा,
तो
ये
लेफ्ट वाला
100%
राइट
it will
चाहिए।
work.
हाँ सही है।
सर वो 2 स्टैक वाला भी हो सकता है।
2 स्टैक वाला भी है, ये भी है, मतलब मेरे दिमाग में ये नहीं आया अभी, ये मैंने पहले ऐसा सोचा था, बाद में मैंने वैसा सोचा, बट दिस अप्रोच विल आल्सो वर्क.
2 स्टैक में भी ऐसे आएगा लेकिन दूसरा स्टैक का ना ऐड करके और उनको
हाँ
रिटर्न पॉप करना पड़ेगा रिजल्ट।
हाँ, but this is little less intuitive, means this one is making more sense to me in terms of relating it, but 2 स्टैक वाला थोड़ा कम समझ में आया मुझे. 2 स्टैक वाला अप्रोच भी लिखते हैं और ये वाला अप्रोच भी लिखते हैं, ठीक है.
Sir, for the 2-stack approach, I have
Sorry?
thought something. Can I say?
Please free
Uh,
to say.
sir,
1 minute.
yeah.
Post order iterative. See, this is what happens if you forget, then it will take a lot of time to come back. I am not
इट इज गुड
practicing
सर,
many
हम
days.
मतलब हम सोचने में मजबूर हो रहे हैं, नहीं तो आप सिखा देंगे और हम बस।
हाँ, तो इतना क्या होगा ना कि इतना देर आपको बैठ के ना, अभी तो एक देखो, जैसे मैं भूल गया तो 40 मिनट लगा, अभी आधा घंटा से यही कर रहे हैं हम लोग, ठीक है. बट अगर आप भूल जाओगे तो इट इज पॉसिबल दैट समटाइम्स यू विल स्पेंड 3 hours. आई हैव स्पेंट समटाइम्स ऑन अ डिफिकल्ट क्वेश्चन, आई हैव स्पेंट 6 hours also, 1 day 2 days also, and even not gotten the solution. But in the process, I don't know, it I think it will help. So थोड़ा सा होता है.
तो
अब
इंटरव्यू
बताओ,
के पहले
आप क्या सोचे वो बताओ. What were you thinking? You tell me.
सर इंटरव्यू के पहले ऐसा कैसा कर सकते मैंने, यू हैव टू प्रैक्टिस इट देन ओनली
Of
ट्रिक
course, you have to practice. Now, I have not seen it in many months, so I've lost it.
Okay.
If you would have asked me this 4-5 months back, within 5 seconds, I would have told. But अभी मैं भूल गया अभी. हाँ, who was saying something? Tell me.
Yes, sir. Sir, we'll have 2 stacks. Can you draw parallelly? Main stack and helper stack.
8 15 20
13 7 5
तो याद हो गया ये वाला. 13 7 and 5. Tell me. एक main stack बना दिया, okay? And
और एक
one helper stack.
Helper stack है.
Okay.
First we'll visit the root node 8.
Helper stack. You will visit 8, okay?
And put it in the main stack.
Main stack, okay?
फिर we'll see if 8 has a child node or not.
8 has a child node 15 and 20, okay?
15 and 20. If it has a child node, then we'll put it in the helper stack also.
15 and 20 like this?
No, only 8.
हटा कर इस तरफ डालना पड़ेगा सर.
इसको क्या बोल रहे हो? 8 को इसमें डाल दे.
हाँ, दूसरा पॉप कर लो.
ठीक है.
जो रूट होगा, रूट को इसमें डालते जाएंगे.
One minute.
And then 15 and 20 I'll put here.
No, sir, 8 भी यहीं रहेगा main stack में.
8 भी main stack में रहेगा. Okay, 8 main stack में रहेगा, फिर
और helper stack में भी 8 रहेगा.
8 रहेगा, ठीक है.
क्योंकि इसके nodes थे, child nodes.
ठीक है.
Then we'll visit the child node. First we will go to the right. We'll append 20 in the main stack and 15
in the main stack.
Yes.
Very good. Okay.
Now
यहाँ पे by the way result भी है, तो हमें यहाँ result भी डालना है. ठीक है.
Now we will see the top of the main stack. It is 15.
15, okay.
अब 15 के भी child nodes हैं.
ठीक है.
तो 15 को भी हम helper stack में डाल देंगे.
Okay.
Then we'll go to the right node of नहीं, पहले right node 7 पे.
7 and 13
7 and then 13.
Okay.
Then we'll again see the top. अब 13 टॉप पे है लेकिन उसके चाइल्ड नोड्स नहीं है, तो वी विल मतलब रिजल्ट में अपेंड कर देंगे और उसको पॉप कर देंगे 13 को.
ठीक है.
Simultaneously we will also see 13 is also not there in the helper stack also. Then we'll come to the 7.
13 is not on the top of the helper stack. That is what you can check.
Yes, top of the
Okay.
helper stack.
Okay.
Then we'll come to the 7th.
7 does not have anything, so you'll put 7 here. 7 is also
Now
not
when
in
we
the
come
stack.
to 15 is there in main stack as well as the helper stack.
Okay.
So we'll append 15 also in the result and remove both like from both the stacks.
Okay.
Then we'll come to the 20. Up 20 has a child node. Then 20 should be appended in the
20 has
helper.
a child node. Okay, 20 has, we will check. 20 will pop and then check if it has a child node. If it has a
Yes.
child node, then you will start put it here.
Put it here, and 20 should also be there in the helper stack because it has a child node.
Child node. Okay.
Now we'll again see the top, like 5.
We'll see 5. Okay.
5
does not have
doesn't
anything.
have
So
anything.
you will put 5 here.
Yeah, put 5 here.
And we'll
Then
pop
we'll
5
come
here.
to 20.
20 is here also and here also.
Here also. Then we'll append in the result.
20.
Then come to 8.
We'll come to 8. 8 is here also, so we'll put 8.
Yes.
So this is 13, 7, 15, 8, 5, 20. Not 8 here. 5, 20. This will work. This is a great
हाँ,
approach.
but problem यहाँ पे सर ये वो काम करेगा लेकिन you're trying to search again and again in the both the things, right? Which will be like times आप 20 का ढूंढ रहे हो ना, यहाँ पे ऊपर है इस तरफ में इसमें वैल्यू में है करके. You're comparing two stacks, right?
Comparing two stacks मतलब क्या? Comparing top of two stacks. So that is constant.
Okay, can we create one more child node for 7 left node and 5 right node?
Let me, whatever, I don't know who was talking. Can you please tell me your name?
Vansh.
तो जो वंश बताया उसका फिर से एक बार ड्राई रन करते हैं. आई थिंक
yes sir.
3 अप्रोच हो
एक और नोड ऐड करके 7 और
3 देखो 3 अप्रोच हो गया. पहले मैं अपना बताता हूँ, फिर वंश का बताता हूँ, फिर एक और थर्ड अप्रोच जो मैंने पहले लिखा था लिस्ट वाला वो मैं बताता हूँ. तो मेरा अप्रोच पहले मैं बताता हूँ. ठीक है, मेरा अप्रोच ये था कि we will put 8. Okay, and then we will pop 8 and we'll put 8 here. Okay, and we'll put children of 8, which is 15 and 20. Okay, then we will remove 20 and we'll put here. Okay, and we'll put children of 20 here, 5. And I think my approach and his approach is similar. I think only that reverse is happening. We'll put 5 here. Okay, then we'll pop 5. Every time we'll pop the top of the stack, we'll put 5 here and we'll put children of 5 here. 5 children are not there. Then we'll pop 15. We'll put 15 here. Okay, and we'll put children of 15 here, which is 13 and 7. Okay, then we'll pop 7 and we will put here. 7 does not have any children. Then we'll pop 13 and we'll put here. So if you look at this stack, this is 8, 20 from top. If you see 13, 7, 15, 5, 20 and 8. This was my 2 stack approach which I was trying earlier.
ये चलेगा सर, फिर रिवर्स कर सकते हो.
It's kind of similar.
ये एक approach हो गया. Okay. The other approach which Vansh told right now, that is also a good approach. What he's doing basically is that he's keeping track of which node has children and which node does not have children. Okay, so suppose he's taking 8. Okay, so putting 8 and 8 here, which means 8 has a child and we are going to navigate children of 8. So 20 and 15. Bunch, correct me if I go wrong. Okay.
Okay.
Then he's popping 15 and putting 15 here, right?
Yeah. No, first we'll check 15 as a child
15
node
has
or
children or not. So he's putting children of 15, which is 7 and 13. Okay. Then he's popping 13. So condition to put here is that if you don't have a child, then we will put transfer from here to here, correct?
Yes.
Valid, very valid. So we'll go to 13. 13 does not have any children. Okay. So we'll do node dot pop. And if not node dot left, node dot right, we will put here. Correct?
No, in the result. We'll put
In the result, sorry. Sorry. So we'll put 13 here. This is not here.
नो
Okay.
एक्चुअली राइट साइड का जो स्टेक है उसमें जिसका चाइल्ड है तो 15 और 20 को भी डालना पड़ेगा हेल्पर स्टेक में.
Once is that correct?
सर थोड़ा इसमें चेंज हुआ है. मतलब 8, 20, 15, 5, 7, 13.
8 सबसे पहले 8 डाला हमने. ठीक है. और 8 को यहाँ भी डाला.
एक.
ठीक है.
हाँ.
फिर 8 के चिल्ड्रन को देखा हमने.
20, 15.
20 और 15 डाला. ठीक है.
अब फिर 15 को देखा कि उसके चाइल्ड नोड्स हैं या नहीं. अगर हैं तो उसको हेल्पर में भी डाल दिया.
15 को हेल्पर में डाल दिया अगर चाइल्ड है तो. ओके.
यस.
15 को यहाँ से हटा दिया.
नहीं,
वहाँ भी
यहाँ पे भी है.
फिर कैसे होगा?
देन सर फिर 15 के चाइल्ड्स
एक मिनट रुको.
20 तो छूट गया ना फिर.
नहीं वो ठीक है, लेकिन 15 को यहाँ भी रखेंगे और यहाँ भी रखेंगे क्योंकि यहाँ पे तो हमने ये नोड डाला हुआ है. यहाँ पे क्योंकि यहाँ पे नोड रहेगा और यहाँ भी नोड रहेगा या नोड डॉट वैल्यू रहेगा. नोड डाल दो, कोई फर्क नहीं पड़ता. नोड ही डाल दो, कोई फर्क नहीं पड़ता. ठीक है, नोड डाल दो. ठीक है. ओके, सो यू विल क्रिएट कॉपीज ऑफ नोड देन.
नोट कॉपीज मतलब एक ही नोड 2 जगह जाएगा स्टैक में.
हाँ, तो 2 रेफरेंसेस बनाएंगे उसके.
हाँ.
ठीक है, चलो. ठीक है, चलो, वो कोई प्रॉब्लम नहीं है. ठीक है. सो यू आर पुटिंग 15 हियर and you will add children of 15 which is
15 in the main stack. 7 and 13.
7 and 13. Okay. And 7 and 13, fine. After that we'll go to the top. We'll always check the top of the stack.
Yes.
We'll go to 13 and
now
13 does not have any children. So you'll put 13 here.
13 in the result.
13 is already there in result, right?
That I added mistakenly, but 13 will come. Okay. 13 is come, then you will come to 7. 7 does not have any children.
Then it will also come in the result.
It will also come. Then you will come to 15 and 15 is in both.
Yeah. So that's why we have to make the copies so that we can know that 15 is the parent.
Fine. That is not a problem. So you'll remove from here, and you will put 15 here.
15, yes.
Okay. And
when
then you'll go to 20. So 20 has a children. So you'll put 20 here and you'll put children of 20, which is 5.
20 here, yes.
Again, we'll go to top of the stack.
Yes.
Okay. And we'll check children of 15. There is no children of 15. So we'll put 5 here. Then we'll go to top of stack, which is 20. 20 is here and 20 is here. So we'll remove 20 and we'll put 20. Then we'll go to 8. So 8 is here, 8 is here, we'll put 8. Try to write this logic.
Sir, one stack से भी कर सकते हैं. I'm thinking loud. Is it okay?
One से मैंने already लिखा हुआ है. ये मैं दिखा देता हूँ आपको.
Okay.
ये मेरा पहले का है जो मुझे खुद ही याद नहीं है अभी. ये वाला कोड you can use. This is the third approach.
So, in the
multiple ways you can think. There can be many different ways of doing it. Tell me, who was saying something?
Yeah, the same approach where you're checking for 20, right?
Checking for
20. I think if it has child node or not. Like.
Sorry, 20 what?
No, so you're ideally so when you reach 20 before adding 5 at the top of the stack, so now you check it is in the main stack as well as the helper stack, and then you added 20. So you added 5 to the top of the stack, right? Now we still have 8, 20 there on the right hand side.
Try to write this one. This logic is there. This is iterative approach. Okay. This is another approach, and this is the first approach that I told. This one, did you get what I did? We'll try to write all of them, all three approaches. Somewhere or the other, this will be useful for you. So this what I did, two stack wala I'm writing. Then we'll try to write once wala. Okay. So I'm saying stack 1, main stack, is containing my root. I'm starting with the root. Okay. And then I'm saying that while main stack,
Since you already got root, okay.
already started with the root. How many of you are lost? Because we are discussing the same thing since a long time. Okay. I hope many of I'm not hoping, but I'm thinking that many of you might be lost. Okay. But try to formulate the logic from scratch. It will only help you. Okay. While main stack, what we will do is we will do node is equal to
left,
main stack dot pop. First we will pop it, because here we have 8. So I'm popping it and putting it in helper stack, right? So I'm popping it. Okay. So node is equal to main stack dot pop. Okay. And helper stack I will create. Helper stack. I'll just call it helper. And let me just call this main. Main, or let me just call it stack. I don't want to write too much. So
no, you're going to add that to the helper stack,
yes,
the
yes,
node.
yes, 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 yes. Node is equal to stack. Okay. So stack dot pop. Okay. Then I will say helper dot push
Or
node
append.
dot val, whatever push append, whatever. Okay.
फिर
Then I will say
left को जाएंगे.
if node dot left. Okay. Stack dot push.
हाँ, main को push करेंगे. हाँ.
Stack dot push node dot left. If
node dot right. हाँ.
node dot right. If node dot right, then stack dot push node dot right. Okay. So if we do this, then our helper node contains our values in reverse order. Okay. So I'm saying we'll put 8. Okay. Then we'll remove this and we'll put 8 here, and we'll put children of 8, which is 15 and 20. Then we'll go to 20. We'll remove 20 and we'll push it in helper. And in the main stack, we'll push children of 20, which is 5. Then we'll remove 5, and I'll put children of 5, which is nothing. Then I will push 15, and I will put children of 15 in this, which is 13 and 7. Then I will again take out 7. So I'm always popping the top of this stack, 7. I'll put 7 here, and then I'll put 13. I'll put 13 here. And this is my stack, which is also my result. So I have to create another list from where I will pop values and put 13, 7, 15, 5, 20, and 8. Okay, so this is my helper stack. From helper stack, I want to create my list. So what I will do? I will do my result. I'll put one result, which is empty. I'll say while helper result dot push or append, whatever. Result dot append. I think this is the simplest one.
Yeah, helper dot pop. Helper dot pop.
Result dot append helper dot pop. Okay. This is the simplest approach so far, what I think. Okay. And then I will return. I will return
result.
This is one approach. I can call it approach 1. ये मेरा वाला है, मैं अपना नाम लिख देता हूँ इस पे, ठीक है? Then this is approach 2. Do a dry run of this on your own, guys. Approach 2. And there is one approach 3, which Vansh gave. Okay. So I will try to write the code for approach 3 and then we'll try to run it on lead code. You guys try to run approach 1 and approach 2. Is that valid?
Yes.
यहाँ पे मैं वंश का नाम लिख देता हूँ. So what was Vansh's approach? Can someone try to put that approach in code if you have understood it? Where did we start? How did we start in that? Guys, try to formulate it. 8, 15, 20, 13, 7, and 5. So he's starting with main stack and helper stack. So let me call it stack 1. Okay. So stack 1 is starting with root. Okay. And there is a stack 2. Okay. And we'll say while stack 1, okay, we are popping the value node is equal to stack 1 dot pop. Okay. Node is equal to stack 1 dot pop. Then what are the things Vansh was telling? That we will check if node dot left and node dot right. If node dot left, we will, if there is a child, then what we will do?
We'll put that also in the main stack, like stack.
We will put stack 1 dot append. Two things we will do. One we'll put in stack 1 and other thing is we'll put in stack 2, right?
No sir, अगर if it है
stack 1 dot
कैसे होगा node equals to stack 1 dot pop, क्योंकि उसके केस में वंश के एग्जांपल में 8 दोनों स्टैक में था.
stack
कर
1
रहा हूँ
of -1 है.
कर रहे 1 मिनट रुक जाइए. मतलब मैं भी इसको लिख ही रहा हूँ, सोच ही रहा हूँ. node 1 dot left, then stack 1 dot push node dot left, correct?
Yes.
पहले first you are doing right.
Right, yeah.
Okay. If node dot right, then stack 1 dot push node dot right. ठीक है. नोड डॉट राइट और लेफ्ट दोनों में डाल दिया. यहाँ पे मैं बना लेता हूँ दोनों स्टैक. तो 8 था और 8 के अगर चिल्ड्रन है तो व्हाट इज योर कंडीशन दैट बोथ चिल्ड्रन शुड बी देयर और वन चाइल्ड शुड बी देयर?
आइदर बोथ और वन, मतलब एक भी हो सकता है.
एक भी हो सकता है. तो एक भी हो सकता है तो स्टैक 1 से किया तो इसको स्टैक 2 में डालेंगे ना यहाँ पे.
यस यस.
इफ नोड डॉट राइट और नोड डॉट लेफ्ट. ओके. तो यहाँ पे हमें वो कंडीशन डालनी होगी ना कि ये कि इफ कंडीशन डालना होगा कि stack 2 dot push node, correct? यहाँ पे वो एक कंडीशन डालनी होगी मुझे. चलो थोड़ा सा ऑप्टिमाइज बाद में करेंगे, पहले यहाँ पे लिख देता हूँ मैं ऐसे, बट नॉट विद द बेस्ट वे. बट यहाँ पे मैं इसको ऐसे डाल देता हूँ. इफ नोड डॉट लेफ्ट और नोड डॉट राइट. ठीक है.
यस.
यही आपने बोला था. कोई एक भी होगा तो पुश कर देंगे, और राइट है तो राइट डाल दिया और लेफ्ट तो लेफ्ट डाल दिया. ठीक है. उसके बाद
सर इसके चाइल्ड नोड्स 8 के 20 एंड 15 स्टैक
8 डाल दिया यहाँ पे. उसके बाद चाइल्ड नोड यहाँ पे डाल दिया 20 एंड 15. ड्राई रन हो गया, यहाँ तक हो गया. वी हैव डन 15. आफ्टर दैट
अगेन
we'll pop 15.
We'll pop 15, yes.
So node is equal to stack 1 dot pop. We will pop it. If node dot left or node dot right.
सर
ओके,
यहाँ पर स्टैक 1 डॉट पॉप की जगह आई थिंक -1 अगर आए तो,
-1 क्यों आएगा?
क्योंकि हम 50 अगर वो पेरेंट नोड है तो स्टैक 1 में भी आना चाहिए, स्टैक 2 में भी, लेकिन
हाँ,
अगर पॉप कर देंगे तो फिर वो स्टैक 1 से हट जाएगा।
स्टैक 1 से हट जाएगा तो हटेगा नहीं, तो फिर तो लूप हमेशा चलता रहेगा ना।
सर ये कर सकते हैं कि जो टॉप पे है स्टैक 1
हाँ
के, वो
हाँ
वहां पे भी जाएगा स्टैक 2 में,
हम्म
ताकि
हाँ,
वहां
मतलब
से
तो
पॉप ना हो।
स्टैक 1 का टॉप फिर वो स्टैक 1 का -1 वैसे आएगा।
स्टैक को यहाँ पे स्टेप बाय स्टेप चलो, ऐसे नहीं। ठीक है, कोड में क्या गलती है वो बताओ। ठीक है, 8 लिया,
हम्म
रूट लिया, यहाँ पे स्टैक 1 में रूट लिया। ठीक है, स्टैक 2 एम्प्टी है। ओके,
हम्म
नोड की नोड यहाँ से निकाला, आप बोल रहे हो कि ये नोड निकालेंगे नहीं, तो अगर आप नोड निकालोगे नहीं,
हम्म
चलो यहाँ पे -1 कर देते, लेट अस डू -1. Okay, so you will take 8 here and you will put 8 here,
यस
this line of code. Okay,
यस
then if node dot right and node dot left, then right and left 20 and
हम्म
15 you will put here.
हम्म
Okay, this whole code has run.
यस
Then what we will do? Again, we will go back to 15. We'll pop 15.
नो नॉट
Means
पॉप, जस्ट
नॉट
पुट
not
पॉप,
अगेन इन
pop.
द स्टैक
We will
वन।
see.
हाँ।
15. This
हाँ
line.
हम्म।
If node dot left and node dot right, then we will stack 2 dot push node. So 15
हम्म
ka chal raha hai, so we'll put 15 here.
हाँ
Okay, and we'll put 13 and 7.
या
So 7 and then 13.
हम्म
This loop has ended. Again, we will come to 13. So we'll put
नाउ
13
13 इज नॉट।
not having any children. Okay.
हम्म
So if node dot left, node dot right. Okay. So we have to write more code here. We will come here and we'll do this. Correct? No? And you'll have to put one else here. That it does not have a child. Then what did you say? We will put answer in. We'll put it in result.
या
So we'll make one result. And you are saying we'll put result dot append node dot val.
हम्म
ठीक है, so we'll have result here. So we'll result में we will get 13. So once we get 13,
अब सर इसको पॉप भी कर देंगे।
then we will pop it. Okay.
हम्म
Stack dot
स्टैक
pop,
1 डॉट पॉप।
stack 1 dot pop. Okay. So now this has been removed.
हम्म देन अगेन द लूप
We'll go to 7.
हम्म
7 also, this condition will not be true. We'll go here. Result dot append 7. Stack dot pop. Okay.
यस
Then again we'll go to 15.
हम्म
15 में क्या होगा? Result dot append. No.
वी हैव टू अगेन
No, it will not work.
put the
It will not
condition.
work. It will not work. At least in this case, it will not work. You see, because when you come here again, this node will be problematic because you will reassign node. Okay, so this it will not work like this. You have to do node is equal to stack 1 dot pop, and then you have to do result dot append. Node dot val. I don't think it will work. Logic is there, but the way we have written the code, it might not work. Do you realize that, or do you think it will work?
सर ये लास्ट वाला नहीं समझ आया,
कौन सा?
अभी जो आपने चेंज किया,
फिर से करते हैं.
रीअसाइन, यू हैव रीअसाइंड द नोड वैल्यू राइट।
हाँ, otherwise node will come here, no?
हम्म
नोड आप यहां से निकालोगे.
नोड
8 से स्टार्ट किया. ओके, 8 का नोड is 8 minus 1. Okay, this is node. Node dot left dot right you are putting
Hmm.
20 and 15 here, and you are putting 8 here
Hmm.
because children is there. Okay, then you are going to 15.
15, yes.
Then you are going to 15.
Yeah.
Okay.
Put 15 in the stack 2 and
Node
children
is 15. 15 node left dot right is there, so stack 2 you will put 15.
in.
You will put children of 15, which is 7 and
7 and 13.
13. Then you will go to 13.
Hmm.
Again we will come here and this code node will be 13. Okay, node is 13. Then fine, we will do
Then it will go
13
to
does not
all.
have any children, so
Hmm.
node is 13. This line of code will not work. We'll come here. We'll
Hmm.
do node is equal to stack dot pop. 13 will be popped, and 13 ka value will put in result.
Hmm.
Correct? Then we will again go to 7. We'll come back here again. Node will be 7. 7 also, this condition will not be true. This condition will be running. Node will be stack. We'll append 7 here. And 7 is also removed. Then we'll come to 15. Okay. Now
Hmm.
15, we have to again check stack 1 and stack 2. So one more condition you have to put here. Are you getting?
Yes, yes.
You have to check
If
that if node is equal to stack 2 ka minus 1,
yes,
then you have to remove from stack 1 also stack 2 also.
stack 2 also. Yeah,
So one more
extra
else condition will come here. That 15 elif, here you have to put one elif. आप अब देख रहे हो थोड़ा कॉम्प्लिकेटेड हो गया लॉजिक, तो किसी को समझाने में दिक्कत होगा. But it is intuitive. What you are doing is intuitive, means it makes sense. But इसमें steps ज्यादा है.
Yes sir.
So what you will do?
मुझसे भी कोड नहीं हो रहा था.
नहीं होगा, 100% होगा. चला के मानेंगे, ऐसा मत बोलो. एलिफ जब तक चलेगा नहीं ना, छोड़ेंगे नहीं इसको, फिर करके ही मानेंगे. एलिफ ओके. एलिफ विल बी व्हाट हियर. कितना टाइम हो गया जी? 7 बज गया क्या? 7 बजने वाला है.
Elif
एलिफ if
stack 1 minus 1 equal to stack 2
1 minus 1 dot val.
Dot val equal to.
See, this thing is tricky. Why? Because value of two nodes can be same. So
Yes.
it can't be stack minus 1. Stack not val, stack minus 1 only. You have to compare the nodes. You can't compare the value because
Or we can compare the nodes.
15
Yes.
ka there can be alag also. Stack 1 is equal to
Stack 2 minus
2
1.
minus 1. Then also
Pop.
result dot append.
Result
है ना?
dot append. Yes. And pop from both the stacks.
Pop stack 1 and pop stack 2. Stack 1 dot pop and stack 2 dot pop. Guys, are you following, all of you others people? Or have you all logged off?
Sir, one thing, right? ये 20 का
We are
child
lost
node
in
है.
this approach, sir.
This approach you are lost. Don't worry. I will bring you back. Trust me.
Hello.
See, even if it does not work, it's a good learning exercise. To see why it is a good learning exercise, because you saw one problem, you thought of an algorithm, and you're trying to convert that algorithm to code. That is the whole purpose of coding, which is, or learning any language, that whatever you thought, you are able to express it. If you are able to do that, then you can say that, okay, you know programming.
Yeah, you're right.
It is not about data structures. It is not about pre-order, post-order traversal. It is not about trees or stack or queue. It is about whatever logic he explained to me in English. Can I convert that English to Java or English to Python? That's what I am trying to do. And this is what you will have to do actually, because I told you that whenever you learn something, you're going to forget it. But if you have learned it from the first principles, then you should be able to recreate it. It will take time, but you will be able to recreate it. For example, I have completely forgotten the approach. So it took me a lot of time to come up with one approach. And one approach Vansh has given, which I don't know, but I'm trying to follow whatever he's saying. I'm trying to convert it to code. And then we'll try to put it in lead code and see whether it works or not. It might not work, but at least we are trying to convert it. It might take 1 hour or 2 hours, or maybe it will take 1 day, but we will get it done. Just wait for some time. Okay, be little patient. And if this condition is true, so we'll remove 15. This condition, if node dot left and node dot right. So this elif will come before this. Once, do you agree? Because otherwise you will again append 15 ka children, 15 ka children here.
Node left and node right.
You have come to 15, correct?
Yes,
If you come, this block of code will run.
Again, yes.
This block of code should not run. First, this block of code should run, correct?
Correct.
So this should come first. That we will keep in mind. Okay. So we have removed 15. Then we'll come to 20. This block of code will work. This is not there. Then we'll go to 15. So we have added 15 here. Till now, are we on track? 13, 7, 15? 13, 7, 15. Then after that, where is 5?
20 ka child.
Uske baad we'll come to 20.
Yes.
So 20 ka children you will put. So if 20 has a children, then we'll put 20 here, correct? And then we'll put 20 ka children. So 20 ka children is what? 5. Again, we'll go to 5. We have taken 5. This condition will not run. Correct? First, this condition will not run.
This
condition will not run. Then
it will go to else.
This condition. Node is equal to stack.pop. Will pop this and we'll put 5 here. Correct, no? Am I going right?
Yes.
Then we'll come to 20. Correct?
Yes.
When we come to 20, then this condition will run.
Yes, first condition.
First condition, हाँ. तो ये हट जाएगा. Correct है ना? Then we'll come to 8.
दोबारा first condition.
8 पे आ जाएंगे. 8 में this condition will run. 8 will go away.
Now stack 1 becomes empty.
Stack 1 becomes empty. Code लिखें क्या इसका? Should be right?
Yes.
If it does not work, then I will make you sit.
No problem, sir.
Okay, chalo. We will try out this code also. ये वाला कोड भी ट्राई करेंगे. ये वाला कोड भी ट्राई करेंगे. ये वाला कोड तो मुझे मालूम है चलता है because I've run it last time. So 2 approaches are there. Okay, chalo, let us write. What did we say? We'll do one result. Okay. Then we'll have one stack 1. Then we'll have stack 1 में क्या डालेंगे? Root डाल देंगे. Then we'll have stack 2. Okay. Then we'll say while stack 1. Okay. Then we'll write 3 conditions. Okay. First is condition 1. Top of stack 1 is same as top of stack 2. Correct? So we'll say if stack, we'll have to make some changes here. If stack minus 1 is equal to stack 2 minus 1. Okay, so here we'll have to check for index error. Because stack 2 can be empty, right? If stack 2, we'll have to write here. Stack 2 end. Okay, so what we will do?
We'll store it in the result and then
we'll do result dot append stack. We'll take out node. We'll say node is equal to stack 1 minus 1 dot. We'll say node dot result dot append node dot val. ठीक है?
Yes, sir.
Then we'll say stack 1 dot pop and stack 2 dot pop. ठीक है? Else elif. What we will do? If node dot left or node dot right, if node dot left or node dot right, okay, stack 2 में push कर देंगे. Stack 2 dot push. Stack 2 dot push node dot val node. If node dot left, then stack 1 dot push node dot left. ठीक है ना? If node first node dot right बोल रहे हो guys?
Yes.
सही कर रहा हूँ ना? Node dot left, then stack 1 dot push node dot right. ठीक है? हो गया ना इतना तक? Last
I
condition?
think our case should be append here, no? Because it's just list as a.
हाँ ठीक है thank you. Append. Fine. Last condition was what? This is our condition 2. Sorry. This is our condition 2. If the node has left or right, if the node has children. And what is the third condition?
If it doesn't have children.
Node has no children. So if node has no children, then we will simply do node is equal to stack 1 dot pop, correct? And result dot append node dot val, correct? And we will return
the result.
Let us run and see.
Sir, RES.
Syntax error is there somewhere. Invalid syntax, elif.
But here also, where your cursor is, stack 2 dot append.
I think there should be some condition else.
Sir, else
if,
तो condition
and
नहीं है.
something condition.
If else, if ऐसे लिख सकते क्या?
If else,
elif node.
ये ठीक है?
if else,
ये ठीक है ना?
yes.
Node dot left. एक लाइन भूल गए ना यहाँ पे. नोड इज इक्वल टू स्टैक -1. कुछ ना कुछ तो एरर आएगा. स्टैक इज नॉट डिफाइंड. स्टैक 1. If node dot left or node dot right.
I think we should add one more condition if node.
We'll have to rethink. We'll have to rethink because if node is not there, then what to do? The edge condition. If not node, stack -1, stack 1 -1. We'll have to rethink. because here also you have to check if node has value or not, because this node may or may not have something. Stack 1 minus 1, in which case if it is like this, see, this is the tree which is 1, null, 2 and 3. Try to think of in this case 1, nothing, 2 and 3. Okay, so what we have to do, we have to ensure that when we are appending something, we're not appending nulls, but we are taking care of that. Stack 1 dot pop node, stack 2 not 1, if node dot right, if node dot left, stack 2 dot append node, stack 1 dot pop. Node dot val. इसको मैं लिखता हूँ, ठीक है? Let us stop here. I will write this code and then I will share it with you. Some edge cases we have to handle. I can see that many things will go wrong in this, but high level this logic is correct. Okay, when we are appending here stack 1 dot pop, it can be a null node, so those null things we have to validate. If I will check and I will share the code. Okay, it will take some time. Give me 15-20 minutes, then I will check it. Guys, today we will discuss only this much. Okay, so we have completed our tree traversals. Okay, so tree traversals we have completed today. Please try to write iterative and recursive code for all of them. Okay, pre-order, in order, and post order. This much we have completed, and we have written code for this. And this writing code is very, very important exercise. You have seen we have spent a lot of time today. And after this, now what we have to do in trees? One more topic is left in trees, which is binary search trees, which is BST. And we have to do some lead code problems on this. Okay, so we'll do binary search trees in the next class. Or binary search is nothing, but it is also one lead code question only. Okay, and then we have to do some lead code problems. So lead code problems related to path finding, maximum depth. Okay, invert a tree, and same tree. Okay, so these questions, for 5 to 10 questions we will do. So we'll target 3 questions on this Tuesday, 3 questions on the Friday. By next week we'll try to wrap up binary search trees, and next 2 classes of this week we will try to figure out graphs. So my plan was that by 3rd week of November I wanted to complete trees and graphs both, but we are late by 1 week because we took, I think, chutti in Diwali also. So graphs we will complete by end of November, or maybe 1 extra class. So with this we will wrap up and graphs, and we will also show you, I'll show you one class, we'll also do heaps. Okay, so we'll try to do by 1st week, end of November also we may not be sufficient. So 1st week of December we'll complete our complete data structures. Okay, so we'll complete array, linked list, queue, stack, trees and graphs and heaps. This much we have completed. So what will be left after that in the remaining 6 classes? Okay, so we'll try to cover our sorting. We'll take 1 class and we'll do sorting, and 1 class we will do 2-3 classes we will do dynamic programming. So dynamic programming, there is no theory, we only have to solve problems. So we'll do dynamic programming. And anything else is there? Recursion we'll do before, and we'll do backtracking. Okay, these 4 topics will be left, which will be your algorithms. Okay, so this is the plan. we have to finish the course by 31st of December. So if we are lagging behind, suppose if we take more time in graphs, then we might do some extra classes towards the end of December. Okay. Of course, if you guys are available, because it will be holiday season, but I'm telling you beforehand. And we will have practice sessions even after 31st December. So I'll keep doing practice sessions where we will keep solving problems. But our agenda will be to complete this by 31st December. All of you are with me on this?
Yes.
Okay. So almost we have reached our end of data structures. Only graph is left. We will end some practice on trees. So we'll do that on Tuesday and Thursday. So please join on Tuesday. We will solve at least 3 or 4 questions on graphs. Trees. Pathfinding trees, max depth, inverted tree, same tree, subtree, this type of problems we'll solve. So all of these problems which we will solve now, they will all be inspired from everything that we have done so far. We have spent a lot of time on this stack and recursion and all of this. So whatever we will solve will be inspired from these solutions. Guys, from today, anyone has any doubt or question, please ask. Except for this code. This I will write and I will share it. Some changes we have to make. But other than this, if there is any question, you please tell me. ये वाला approach please solve on your own. Iterative wala. Anyone has any questions, guys? Please tell me.
So if you just go back to your code, I mean,
which one?
The codes which you've written in for lead code also. Now in the def you have put in the brackets these
Where?
nomenclature inside definition under the first line under class solution. This is what is this format? Is there a structure for that? What is this?
This is a structure that lead code gives.
Okay.
Because
yeah, please go ahead. Yeah.
So because lead code has to run this in their backend. So this is the format that lead code will have for any solution. That there will be a class called solution. Inside that there will be a function and we have to write that function.
So you mean this is a representation of the diagram, I mean, or the tree structure?
No.
It's just
this
a nomenclature.
This root is a structure of tree. This root is a tree. ये जो रूट दिया हुआ है ना, ये रूट एक ट्री है, बट ये हर कोड में रहेगा ऐसा ही.
अच्छा, ये option and you have this lot of terms like traverse and all. I didn't get this.
Where?
After root we have options and.
This is type hinting, nothing. When we write functions, we do this, no? When we write any function, suppose we do add. So I told you, no, that we can write like x and we can say integer.
Yeah.
Y is equal to something and then it will return integer.
Yeah.
So this optional is nothing but this is pydantic. Not pydantic, sorry, typing. So from typing module you will get it. So it is saying optional means here we may or may not pass something, and whatever we are passing should be a tree node. Tree node object is defined here.
Okay.
So typing module, if you go there, you will see these things. We have not covered that in our Python module.
Okay.
Not very important.
Adding to that, you have put an arrow mark and mentioned as list int. I have found this thing. What does it signify?
I have not done that. It is already there.
But
it means that it is expecting a list as a result.
Okay.
I told you, no, we can do like this def add x
integer. Yeah, but I have not noticed most of the coding that arrow mark and listing.
It is optional. It is optional. It is for someone who's reading your code to understand that, okay, this function is supposed to return a list.
I know.
List of what? List of integer.
Integer type. Okay.
Even if I remove this, it will not make any difference.
Okay.
Yeah.
It is just an indication for better readability.
Okay.
So we can call it as type hint.
Type hinting, yes.
Yeah.
Okay, but it's not a mandatory stuff to be written.
It's not a mandatory thing. You can remove it.
But in Python 4, maybe they are using this kind of mechanism. Python 4 is not coming, but
Python 4?
Python 4, sir, is not coming. But from those also, they are following this kind of type hinting mechanism. It's mandatory.
Python 4, I don't know what is Python 4.
Yeah, Python 4 is a new thing, sir. New things it will come.
What is, I don't know.
No, Python version 4, I am telling.
I guess
Version
3.14 is saying because that is the current version.
3.14. Python 4 has not come. 3.14 is the latest one.
yeah, Python 4 is not coming. It will come. I think it is in beta stage only that.
Okay.
Yeah, maybe they are following with the similar type kinting mechanism that.
Type hinting is
And
there
also,
already since
That
long time.
we
is
follow
also
already,
there.
sir.
Okay.
Type hinting is already there. It is optional.
Yeah.
What is type hinting? I mean, I didn't get this.
टाइप हिंटिंग का मतलब है कि जैसे आपने कोई फंक्शन लिखा है यहाँ पे. Guys, class is over. Those who want to go, you can go. I will sit for some time. Okay. This is not pydantic technically, but pydantic also you can use to create some data classes. Say, for example, you are writing add. Okay. So suppose you are doing x and y, and you are returning x plus y. Okay. And you are calling this function add 4 and 5. Okay. So you are getting this result. Now, instead of doing this, if you are expecting x to be an integer, so you can say that this is an integer.
Yeah, data validation.
And you can do int. This is not validation, by the way.
Okay.
And you can say that this is int.
What we say in the Java boxing, right?
जावा में मैंडेटरी होता है, जावा में ऐसे आपको लिखना पड़ता है ना int x. इसमें वैसा नहीं है क्योंकि डायनामिकली टाइप्ड है ना, तो आप x ऑटोमेटिकली वो अज्यूम कर लेगा कि x क्या है y क्या है. ये बस रीडेबिलिटी के लिए है.
Basically, it is just programming practice. कि अगर if as a developer I will be replaced next day, so if some another developer is coming, you don't have to do a proper debugging of values and seeing. He'll understand that this function will take these two values and they has to be passed as integer.
करेक्ट. तो यहाँ पे आपको और भी गुड प्रैक्टिसेस होते हैं जो पेपेट में आपको लिखना पड़ता है. यू विल राइट दैट दिस फंक्शन विल ऐड two numbers x and y. Then you will write here params. You will say x number 1 to be added. Then you will say y number 2 to be added. Okay, then you will return returns. Then you will return sum of x and y. Like this you will write. So this is like a doc string.
Yeah, it's a doc string.
So this also you should write. This also. So these are good practices of writing the code.
Okay, because I have noticed pydantic, but it has a more
so this what you are seeing here, this optional tree node, all of this is coming from a module called typing module.
Okay.
ये नोट सेक्शन भी आप अपलोड करेंगे क्या सर?
From typing, sorry.
नोट्स जो आप ये ड्राई रन वगैरह जो कर रहे हैं उसको कहीं सेव करते हैं क्या?
हाँ, गूगल ड्राइव में है ना. रोज मैं बताता हूँ ये चीज. गूगल ड्राइव में जाओ.
गूगल ड्राइव में
वो लिंक मैंने दिया है ना. कहाँ है वो? यहाँ पे डाला हुआ है ना. ये देखो 22 नवंबर कल का नोट्स है ना यहाँ पे.
अच्छा, गूगल ड्राइव का लिंक एक बार इसमें व्हाट्सएप में डालेंगे.
रोज मैं व्हाट्सएप पे शेयर करता हूँ.
Sir, I
रोज मेरे
request
से कोई
you,
मांगता है.
sir, please add it daily, sir. Makes sense because
you check
it
in the
becomes
group.
handy.
Wait. I will add it. I will add it now.
It becomes handy. It's a
lot of new people are joining. No,
even old people, sir. I'm an old student.
You're old. Then why you are asking?
Sir, no,
then
sir.
I will not share.
No, sir, please, sir, because it becomes handy.
Sir, you can
it's in the chat.
In the group description. No?
Huh? Group
Add in the
description.
group description. Huh.
Are you add it in your bookmarks, no?
Bro, you work in that. Sometimes you are working in so many projects, it becomes difficult to search which end. So
bookmark, create one bookmark here. Euron.
Sir, can you ping
my
me the link?
laptop is full of bookmarks, sir. I know.
Okay.
I mean, it becomes handy.
Whenever you need, you message me personally. I will share.
Sir, message me. आप डालो sir. You can just put it in the chat. It makes sense.
Okay, all of you are clear. Any questions, doubts?
What is the agenda for the next class?
Next class agenda, we'll see next class. I told just 5 minutes back. No, this is the agenda.
Yeah, sorry, because it's late night.
We will do problems, lead code problems. We will do. Today I was planning to do 2 problems, but we got stuck in that thing. But we'll do 4 problems. So Tuesday we will do some problems. Tuesday and Thursday we will see if we are able to do good problems. And Thursday we'll start graphs. If not, then next class also we will do some. Next class, I think next Saturday we'll do some tree problems. If we are able to do tree problems in Tuesday and Thursday, if I'm able to take the live classes, then we will start with graphs. That's the agenda.
Sir, I mean that typing. Can you show me what are the? Okay, I'll check my solutions. I know.
You can see. You can see.
No, I wanted to see what all things are there under that.
You can see Python.
Sir,
Typing module.
yeah.
I have not used typing the feature.
Python. You can go here.
Of course, I've used it.
It says Python runtime does not see. It does not enforce variable and type annotation that can be used by third-party tools called type checkers and all. But here you can see. Consider the function. Here you see this type checking. Not type checking. Type hinting. Okay, so you can read the description here and you will see list is there, float. You can create so sequence, dictionary, tuple. So here you can see it is taking a sequence. Here it is taking a string. So you can do a lot of type hinting like this.
Fine. Yeah.
So you can create, you can read here, or if you go here typing, you will find like list.
Yeah, I wanted to see from this end actually.
List, and you will see optional.
Doesn't show when you click on that shift and tab.
थोड़ा सा collab is little bit slow, but you can see
सर
like this.
आपने ऑप्शनल का वो जीरो किया इसलिए वो नहीं आ रहा।
क्या?
वो जीरो लिखा है आपने।
ऑप्शनल कहाँ पे?
नहीं
ठीक है ना?
Because I feel a lot of things under typing, I think, which I'm not.
Explore, read the
Yeah,
documentation.
that's what I said. I'll take care of it.
Yeah. Okay, guys, I will see you.
Sir, one code. Actually, can we just not the code wise, just retrace the logic ones, just the numbers and the values, nothing with respect to code.
This one?
Empty. Yeah, just empty stacks and the.
You want me to do one run on this?
Yes, the same graph. Like
same. Okay. So what is what is the approach? You will take the root. Guys, those who want to leave, you can leave, please. Okay. We'll take root here. Okay. And if the root has children, I will add it here. And I will add the children of the
20 and 15.
Okay. Then I will take 15. I will check if 15 has children. Then I'll put 15 here. Then I'll put children of 15 also, which is 7 and 13. Okay. Then I will take out 13. If 13 does not have any children, then I will remove it from here and I will put it in the result. Okay. Then I will go to 7. 7 does not have any children. So I'll remove it from here and I will put it here. Then I'll go to 15. 15 and 15 is matching. Then I will remove this and I'll put it here. Then I'll go to 20. 20 has children, which is 5. So I'll put 5 here and I'll put 20 here.
Okay.
If it has children. Then I'll go to 5. Okay. I'll go to 5 and 5 does not have any children. So I will remove it and I'll put 5 here. Okay. Then I will go to 20. 20 is here also. So I'll remove it. And I'll put 20 here. Okay. Then I'll go to 8. So 8 is here also. So I'll remove 8 from here and I'll put 8 here.
So in our case, we have at the point 15 first time before inserting the child nodes. So we had 8 and 15 on the other side of the stack.
Yes, we are creating a copy.
Correct. Copy. Now, once we add it, how do we know that I will not again check that 15 is as a child node again? Because I mean, how do we ensure that that's
because when there is a child node, I'm adding it in both places. So if here also it is available, here also it is available, that means we have checked the children already. Children are processed, so we can remove it.
Okay, the on check is if both the top of the nodes are same, stacks are the
so
same.
3 conditions are there. One, when there is children, when both are same, both stack top is same, and third is when there are no children. So these are the 3 cases. But some null handling issues are there in the code that I will figure out. Then I will give this code to you. But otherwise, 2 other approaches I have given here. One is this one, and other is this one.
Yes. Okay. Code sharing issues. Thank you.
Okay, guys. Thank you. Bye. Take care, and I will see you on Tuesday. Tell.
हेलो सर, एक्चुअली रिसेंटली मैंने 2-3 बैच ही अभी स्टार्ट किया है, तो क्वेश्चन मेरा ये था, मैं कैचअप कर रहा हूँ अभी एक्चुअली जो आपने पढ़ाया है। सो यहाँ तक कोर पाइथन तो पता है मुझे, टिल मींस फंक्शन एंड क्लासेस, तो ये जो प्रैक्टिस हम कर रहे हैं ये लोकली विजुअल स्टूडियो कोड में और जुपिटर नोटबुक में कर रहे हैं या लीड कोड में जाके टाइप
दोनों
करके?
जगह कर सकते हैं, आपकी मर्जी है।
अच्छा।
लेकिन क्या होता है कि जैसे ट्री और ग्राफ है ना,
हम्म।
ट्री ग्राफ और लिंक लिस्ट, तो उसमें जो क्वेश्चन
हम्म।
दिया रहता है तो वो क्वेश्चन भी आपको, अगर आप जैसे खुद से प्रैक्टिस कर रहे हो
हम्म।
तो आपको वो बनाना पड़ेगा,
ओके।
तो वो उसमें टाइम वेस्ट होता है। तो
हम्म।
वो चीज आप लीड कोड पे प्रैक्टिस कर लो, लेकिन अगर आप अरे स्ट्रिंग ये सब कर रहे हो
हम्म।
तो ये आप खुद से भी कोड लिख सकते हो।
अच्छा।
ठीक है, तो आप यहाँ पे देखो, जब मैंने यहाँ पे जब जैसे रिवर्स स्ट्रिंग वाला लिखा है यहाँ पे,
हम्म।
तो ये सब आप लोकली रन कर सकते हो।
हम्म।
लेकिन जब आप जैसे लिंक लिस्ट पे जाओगे, ट्री पे जाओगे, तो ट्री में क्या होता है ना कि यहाँ पे ट्री बना के आपको दिया गया है, उसके ऊपर आप लॉजिक लिख रहे हो।
हम्म।
जैसे ये रूट आपको दिया गया है एक ट्री बना
हम्म।
के, तो ये ट्री
हम्म।
पहले आपको बनानी पड़ेगी खुद से,
हम्म।
तो आप खुद से बना के कर लो तो अच्छी बात है।
ओके।
नहीं तो आप अपना लॉजिक खुद से लिख लो पेन पेपर पे,
हम्म।
फिर लीड कोड पे उसको ट्राई कर लो।
अच्छा। ओके। सो ट्री
हाँ
बनाना मीन्स दिस लिस्ट में जैसे 1 नल 2 3 लाइक
हाँ हाँ,
दैट?
लिस्ट नहीं, लिस्ट नहीं, यहाँ पे लिस्ट के जैसा इसको रिप्रेजेंट कर दिया है, लेकिन ये
ओके।
लिस्ट है नहीं। तो आपको
ओके।
कैसे बनाना पड़ेगा, आपको एक नोड बनाना पड़ेगा पहले।
ओके। ओके।
आप एक नोड बनाओगे, नोड 1, ठीक है, इसको
हम्म।
आप बनाओगे रूट, फिर
हम्म।
आप बोलोगे रूट डॉट लेफ्ट इज इक्वल टू, फिर आप एक नोड बनाओगे, दूसरा नोड बनाओगे नोड 2
हम्म।
इक्वल टू नोड 2, नोड ऑफ वैल्यू 2, फिर आप
हम्म।
बोलोगे कि रूट डॉट लेफ्ट इज इक्वल टू नल, रूट डॉट लेफ्ट इज इक्वल टू नल, रूट डॉट राइट इज इक्वल टू नोड 2,
ओके।
तो 2 जुड़ेगा यहाँ पे, फिर नोड 2
ओके।
डॉट लेफ्ट, ऐसे करके आपको बड़ा सा ट्री बनाना पड़ेगा।
ओके।
तो वो
वो
वेस्ट ऑफ टाइम है।
अच्छा। ओके।
तो
ओके।
यहाँ पे ये बना हुआ है आपको पहले से, और जब आप रन करोगे तो अलग अलग इनपुट्स पे आपका कोड टेस्ट होगा। तो
ओके।
बेटर
ओके।
है कि आप लीड कोड पे ही प्रैक्टिस कर लो उसको।
ओके। और ये कोलैब का शीट दिया है, दैट इज राइट? तो
हाँ,
दैट इज फॉर मीन्स वहां पे भी प्रैक्टिस कर सकते हैं डायरेक्टली रन करके?
यहाँ पे
दैट
भी
इज।
नहीं रन होगा, क्योंकि जैसे यहाँ पे ये क्लास सोल्यूशन है, ये
हम्म।
मैंने सिर्फ एक जगह डाल दिया कि सारा कोड एक जगह रहे आपके लिए
ओके।
बस,
ओके।
लेकिन ये यहाँ पे रन नहीं होगा, क्योंकि ये जो रूट है, ये
इज
रूट
नॉट
आपके
अवेलेबल।
पास है नहीं ना, ये लीड कोड प्रोवाइड कर रहा है आपको।
हाँ, बराबर।
तो ये यहाँ पे
करेक्ट।
ऐसे रन नहीं होगा, लेकिन ये देने का पर्पस ये है कि जब आप रिवाइज करोगे तो कॉमन क्वेश्चंस और उसका अप्रोच आपको दिख जाएगा, तो आप उसको देख सकते हो। मतलब
ओके। ओके।
आई एम नॉट इन फेवर ऑफ गिविंग दिस, बट मेनी स्टूडेंट्स आर आस्किंग, दैट्स व्हाई आई हैव क्रिएटेड दिस।
हम्म।
Otherwise, all your lead
अच्छा।
code solutions will be present
हम्म।
in your submissions when you go. So you can revise that, but people like it this way, so I've created this.
अच्छा। ओके। और लीड कोड पे जाके वहां पे लॉग इन करके अपने उस पे ही मतलब प्रैक्टिस करना पड़ेगा, राइट?
हाँ,
अपने अकाउंट
लीड
से ही,
कोड पे जाओ,
राइट?
यहाँ पे साइन इन कर लो।
हम्म।
साइन इन करने के बाद आप प्रॉब्लम सॉल्व करना स्टार्ट कर दो। कौन कौन सा
ओके।
प्रॉब्लम सॉल्व करना है उसका लिस्ट मैंने यहाँ पे दिया हुआ है।
ओके।
इसमें से रैंडमली कोई भी क्वेश्चन आप पिकअप करो।
हम्म।
स्पेशली जो मैंने यहाँ डन कर दिया उसको पहले आप सॉल्व कर लो, जब वो हो जाएगा तो जो मैंने डन नहीं किया है उसको आप सॉल्व करो।
ओके।
जैसे वैलिड पैलिंड्रोम ये सॉल्व कर दिया मैंने, इसको क्यों नहीं डन किया, यहाँ पे डन कर दो, ठीक है। और कुछ कुछ क्वेश्चंस में हमेशा जैसे ब्राउन कलर में मार्क किया हुआ है,
हम्म।
तो ये सब मैंने सॉल्व नहीं किया है, जो मैंने बोला है कि आपको सॉल्व करना चाहिए, तो वो आप अटेम्प्ट कर सकते
ओके।
हो। हाँ, इसमें कुछ कुछ क्वेश्चन है जो हार्ड है, तो हार्ड वाले को अभी रहने देना, बाद में अटेम्प्ट करना, पहले इजी फिर मीडियम फिर हार्ड करना।
ओके।
तो ये क्वेश्चंस होते हैं ना लीड कोड पे, इसका लेवल होता है,
हम्म।
जैसे ये इजी है,
राइट, या।
कुछ क्वेश्चन मीडियम होते हैं, कुछ क्वेश्चन हार्ड होते हैं।
हम्म।
तो इजी और मीडियम हम लोग करते हैं।
अच्छा, ठीक
हाँ
है।
हाँ।
Yeah. Sir, just one
थैंक्स
quick
थैंक्स
question.
थैंक यू थैंक यू।
थैंक यू।
Sir, just one quick question. Actually, tree and graph are similar. Why do we can all the problem to solve in graph, right? Why do we need a tree?
You will understand when we learn about graphs.
Okay, because it can be bidirectional and directional, right? So that's why
Yes.
I'm asking.
It,
So
it it's not like that.
we,
Tree is having separate algorithms, separate work. Lot of algorithms of trees will not work in graphs.
but the problem is we can solve, right? Any all the similar problem. What? How are we moving at
Not
all?
efficiently. For
It's
example,
not
you want to
okay.
do binary search tree. You cannot do it that using graph.
Okay. Mm-hmm.
So tree is
Okay,
separate, graph
let's
is separate.
graph is separate. Okay.
हाँ.
Yeah, when
Conceptually,
you
tree is
take
a type of graph, but lot of algorithms on trees will not work on graphs.
Okay. Yeah, when you take the class and show me the differentiation, let
We
me know
will
the
do
difference.
100%. We'll do next class, next or next to next class. We'll do graphs.
Okay. Okay, sure. Okay.
Thank you guys. Bye.
Thank you.
अच्छा या थैंक यू या बहुत ही इंटरेस्टिंग क्लास था यार आज का भी तो
हाँ
और एंगेजिंग भी है एक्चुअली
हाँ
मैं बहुत मतलब
Yeah,
बेटर
but
फील कर रहा
your
हूँ एक्चुअली
side,
वो
आफ्टर अटेंडिंग
एंगेजिंग इसलिए था क्योंकि मैं भूल गया था, नहीं तो मैं कोड लिख के आगे बढ़ जाता। तो आप
yeah,
पहले वाला वीडियोस देखोगे तो उसमें इतना बैक एंड
हाँ
फोर्थ
हाँ
नहीं होता है। वो आज
हाँ
मेरा
राइट
दिमाग काम नहीं कर रहा है तो
अच्छा अच्छा
हाँ, लेकिन जो सोचने का
yeah,
मोटिवेशन है।
yeah.
राइट
So, yeah, your side will be phenomenal job, sir, but our side only we have to work on this from our end.
या बहुत
We work
प्रैक्टिस
on
चाहिए
effort.
Practice consistently, do 2-3 problems every day. Okay, slowly it's like building muscle, mind muscle.
हम्म
It will come slowly. At least 3-4 months you have to do consistently. Then it will
Okay.
come.
All right. Okay.
ठीक
Okay, guys. Bye bye.
थैंक यू सर नेक्स्ट सेशन वीकडेज में होगा या इट इज
Our official sessions happen only on Saturday, Sunday. Unofficially on my YouTube channel, I do some live sessions on Tuesday and Thursday, 9 p.m.
9 p.m.
where we don't discuss any theory, we just solve some problems.
Okay.
It is like
And
an additional help.
a channel name something
Channel name is called Codevera. This is the channel.
Code Vera, I think code.
Codevera. Please like, share, and subscribe. Thank you.
Okay.
Yeah.
Sure.
Sir, will you be part of the syllabus right now? Will you cover the sorting and dynamic programming?
Yes. 100%. That's what I told some time back.
Yeah, but it's not mentioned that in the
Here I've written 6 classes, 31st December, sorting, dynamic programming, recursion, backtracking, everything we will do.
Okay. Yeah. But we have just seen the regression as well, right? In the one of the right now recently.
What? Recursion?
Yeah, recursion we just see.
Recursion also
just
we'll do. See, recursion is not a separate topic. Some problems need recursion. You already know familiarity with recursion. Separately also we'll try to do recursion few problems.
Okay.
But mostly we'll focus on DP. This is the more important topic.
So this is part of the non-linear or linear?
It is not a data structure. It is an algorithm.
So purely algorithm. Okay.
It is an algorithm. We are learning DS and A, correct? So till now we are doing DS. Then we'll move to A.
Oh, algorithm. Okay. Okay, sir. It's a biggest but not so we are not a big target. It's very difficult.
Everything will come in place. Don't worry.
Yeah, sure.
Okay, thank you guys. Bye.
Thank you. Bye.